So let's start with the introduction to cloud computing. I will be discussing all those topics which I'm discussing today once again in more detail. But yes, still, this particular session is going to be really very important because it is an overview session in which I'm just going to give you the overview of cloud computing. What is cloud computing? Why it is important? Its key features and all. So let's move further. So simply, what is cloud computing? Why is cloud computing important today? Key benefits of cloud computing service model, different models are there, and types of cloud deployments. So this is the stuff which I'm going to discuss with you right away. First of all, let's talk about the part one, that is what is cloud computing actually. So when we talk about cloud, cloud computing is actually the computation where the cloud is involved. And now this cloud is simply the place where we are storing our data on a server, you can say. So, cloud computing is the on demand delivery of computing resources such as servers, storage, database, networking, software, and analytics. So, it is not only a server like a, you can say, Google Drive. No, actually, it is having different features. You have the server also, storage also, databases are there, networking like powers are there, softwares, different softwares are there which can be used. We will be talking about them in very detail further in the upcoming sessions, you can say. And the analytics can also be done right away on the cloud itself. So simply, cloud computing is the on-demand delivery of computing resources such as servers, storage, databases, networking, software, and analytics over the internet, commonly known as the cloud. And this particular all combo, you can say, the combination of all of these is actually known as the cloud. So instead of owning and maintaining physical infrastructure, businesses and individuals can access computing power as a service, typically on a pay as you go basis. Pay as you go means whatever you are using, only for that particular you are going to pay. So let's talk about why is cloud computing important. Okay. So simply rapid digital transformation. These days, if you are going to store everything offline, so it is going to be difficult. You like everybody is having a lot amount of data, multimedia we are having. We are not only having the files, normal files, documents or something, Excel, PPT and all. We are having multimedia. We are having videos. We are having images. We are having, you know, whole bulk amount of data today in today's era, you can say. So businesses are shifting towards digital solutions and they require scalable and efficient IT resources. Now businesses are also storing their data online, simply on the digital medium, you can say. And yes, they take help of the online resources like cloud computing, because if they are going to maintain everything inside their copy paper or registers offline, so that is not going to be helpful. Like there are the MNCs and different companies are connected to each other, different branches are there, and the data is shared. So like register will be not like going from one department to another or one office to another branch via PN or something, because now the cloud is there and the things are connected through network. So simply the data transmission is very easy, and digital solutions are getting provided by the cloud computing, you can say, in the IT companies. Then remote work and collaboration. So cloud services enable employees to work from anywhere. Now this is the point what I was saying before, that simply wherever you are, either you are at home, you are at your office or anywhere else, because cloud services are online through internet. So simply if everything is present there only on the cloud, so you can access it from anywhere, anytime. Cloud services enable employees to work from anywhere with access to the shared resources. So multiple employees in a company, a team, or maybe there are some like read, write, execute permissions and all dedicated to different levels of the employee in the company. But yes, there are shared resources. Big data and AI is also there. So cloud platforms provide high performance computing needed for data analytics and artificial intelligence applications. So cloud platform provide high performance computing needed for data analytics and artificial intelligence applications also. Now, simply the fourth point could be cost optimization. So here the cost is very minimum as compared to the offline infrastructure when you store the data on you know, warehouses, offline, you are storing the stuff. So instead of purchasing and maintaining expensive hardware like hard disk you are purchasing or something, businesses only pay for what they use with the help of the cloud computing pay as you go basis. Okay, we will be talking about in very detail about this. So security and compliance. So leading cloud providers offer advanced security features also. Regular updates and compliance with global standard is there. So leading cloud providers are there like AWS, Azure, Google Cloud Platform. There are so many. We will be talking about them in very detail afterwards. Now, simply the third part is here, which is key benefits of cloud computing. What are the key benefits? What are the benefits? What benefits we are getting through it? So simply scalability. Businesses can scale resources up or down. So there is the provision that you do not have to stuck. You are not stuck. You do not have to stick towards something. That okay, I have 1 TB only. Now what? So simply if you are having cloud services with you, so you can scale up, scale down very easily on the demand basis. For example, an e-commerce platform can handle high traffic during sales events and sales down afterwards. Then when we talk about the second, you can say cost effectiveness. Along with the scalability, you get the cost effectiveness. No need to invest in physical infrastructure. Pay as you go model reduces upfront cost and lower maintenance expenses as cloud providers manage updates. So simply cost is reduced. Then simply the security is also there. Advanced encryption and authentication mechanism is there. Disaster recovery and backup solutions are there. So simply compliance with industry security standards like ISO 27001 and GDPR and HIPAA, that is HIPAA. We will be talking about them in detail further. So simply there are, you can say, multiple benefits. And next, we move towards the cloud computing service models. So there are models, different models, three different models are there. So simply infrastructure as a service is the first model, you can say. IaaS it is known as. And IaaS provide virtualized computing resources over the internet. It offers flexibility in terms of computing power, storage, and networking without requiring businesses to maintain physical hardware. So simply IaaS provides virtualized computing resources. Okay. And now simply when we talk about the different examples of IaaS, so AWS, that is the Amazon Web Services, they provide EC2, sorry, that is Elastic Compute Cloud. So simply as I'm telling it again and again, I will be discussing them in very detail afterwards. I'm just trying to give overview right now. So it provides virtual servers to run applications. When we talk about the Google Cloud Platform, so Google Compute Engine is there. It offers a scalable and flexible cloud infrastructure. Microsoft Azure is there. So in the Microsoft Azure, VMs are there, virtual machines are there. They enable businesses to run multiple operating systems and the environment on cloud itself. Then the next thing which comes into the picture, that is the PaaS, that is the PaaS, that is the platform as a service model. So PaaS provides a platform that allows developers to build, deploy, and manage applications without worrying about the underlying infrastructures. Like simply, you don't have to worry about any underlying infrastructure, that how you are going to deploy and manage the things. So in the context of Google Cloud Platform, if I talk about the example, so Google App Engine is there. It automatically scales applications based on demand. When we talk about the AWS, so there's the AWS Elastic Beanstalk is there. Beanstalk is there. So it helps deploy and manage web applications using popular programming languages. When we talk about the Microsoft Azure, so Microsoft Azure app services are there. It enables rapid web and mobile application development. Then simply the third one which comes into the picture, that is the SaaS, which is known as the software as a service model. SaaS provide fully functional applications over the internet. So users don't need to install or maintain softwares. They access it through a web browser. Okay. It is like fully managed. You just have to directly use it. Then applications are the Google Drive. In the Google Cloud Platform, Google Drive is there, Dropbox is there, Gmail is there. So Google Drive, like simply it is cloud storage and file sharing service. Dropbox, you must have heard about it. Like it is online storage. and file synchronization service. And when we talk about Gmail, Gmail everybody use in our daily lives. You all know it very well. So simply the cloud-based email service it is. They all are using these cloud services definitely. And which is coming in which particular category, you must be getting some idea. Although, as I am saying again and again, it is going to be in very, very detail afterwards. In depth with multiple examples, I will be discussing it. Now coming towards type 5, sorry, part 5, that is the types of cloud deployments. So simply the first one is public cloud. So public cloud is one type of deployment where like it is hosted and maintained by third party cloud providers. So as it is known as public cloud, so definitely third party is involved there. Resources are shared among multiple users. So multi-tenant system also it is known as multi-tenant system. Some examples are AWS, Microsoft Azure, Google Cloud Platform. We are going to discuss about them in detail, and AWS would be the major one. Then simply like public cloud. Okay. Second is the private cloud. So simply the exclusive to private means it is private. It is exclusive to single organization, offering greater control and security, and it can be hosted on premises or by a third party provider. For example, company owners are there, so company owned data centers, VMware clouds in the virtual machines are there in the Azure. So in the Azure, VMwares are there for the private cloud. Then third one which comes into the picture, that is the hybrid cloud deployment, which is hybrid and multi-cloud strategy, you can say. It is following multi-cloud strategies because hybrid means mixture. There are multiple type of cloud computing services involved into the hybrid model, hybrid deployment model, you can say. So when we talk about the hybrid cloud, it is a combination of public and private clouds, because we have already talked about that there are two different, that is the public and private. So definitely it is a combination. Hybrid is a combination of public and private cloud to balance the flexibility and security features. Then when we talk about the multi-cloud, so as I have written here, hybrid and multi-cloud strategy. So when we talk about multi-cloud, so it uses multiple cloud providers to avoid vendor lock-in and improve redundancy. Here, like you are using different cloud services, different vendors. So simply the redundancy will be reduced. If some particular server is down, you will be able to maintain it through different server, definitely the data. So it will be like there will be no data loss in such cases. Example could be like a company might use AWS for hosting application, Microsoft Azure for databases, and private cloud for sensitive data. So this way, the hybrid and multi-cloud strategies can be implemented when you are in an like infrastructure or organization you are going to deploy on the cloud. So simply, cloud computing is a game changer in today's digital world, offering businesses and individuals the ability to access computing power, storage, and services without heavy upfront investments. By understanding the different service models like IaaS, PaaS, and SaaS, and deployment options like public, private, and hybrid, organizations can leverage cloud solutions effectively and efficiently for improved scalability, security, and efficiency. So I hope this much is clear. So we have talked about the introduction to the cloud computing. And right now, I'm going to start with the key technologies in cloud computing itself. So whatever I will be discussing, that is going to be in very detail afterwards also. Not right now. It's going to be an overview right away. But yes, further I will be discussing these things in very detail according to the requirement. And what stuff I'm going to discuss right away, that I'm going to show you. So virtualization and containers, then cloud storage and database management, then serverless computing and edge computing. This is the stuff what I'm going to discuss right away with you. So simply the virtualization and container when we talk about. So there comes the concept of VM, that is the virtual machines and the hypervisors. So like when we talk about the virtual machines, so a virtual machine, that is a VM, is an emulation of a physical computer that runs the operating system and applications on the top of hypervisor. A hypervisor, what is it? A hypervisor is a software program that creates and run virtual machines. Hypervisor itself is used to run the virtual machines on a single physical computer, and it is also known as the machine monitor (VMM). Like the hypervisor, I'm telling you, allocates resources like memory and processing power from the host computer to the VMs, and each VM virtual machine acts as a complete computer itself with its own operating system and program. So virtual machine, what is that? A virtual machine is an emulation of a physical computer that runs on the operating system and applications on the on like top of the hypervisor. When we talk about the hypervisors, they are the software that creates and manages virtual machines by allocating resources from the host machine. So hypervisor basically allocates the resources to the virtual machines. And there are two different options, two different types, you can say, type 1, type 2. Type 1 is bare metal hypervisors, and type 2 is hosted hypervisors. So when we talk about the bare metal hypervisor, that is the type 1. So they run directly on hardware. For example, VMware, ESXi, and Microsoft Hyper-V. These are in the type 1 category. You can say bare metal hypervisors. And the type 2 are like hosted hypervisors. They run on an operating system like a virtual box or VMware or workstation itself. Then when we talk about container versus virtual machine, so there comes a concept of Docker and Kubernetes. Although I'm not discussing Kubernetes or Dockers here, but yes, Docker, Kubernetes, as an example, I will be using. So when we talk about the container, so containers are basically lightweight. They are lightweighted, standalone, and portable software packages that include the applications and its dependencies, but share the host kernel. So host operating system kernel is shared when we talk about the container. They are lightweight, standalone, and portable packages, but its dependencies are like on the shared host kernel. When we talk about Docker, a popular containerization platform it is that enables developers to package and deploy applications efficiently. Okay, efficiently. So simply Docker is an example of container, you can say. And Kubernetes, like it is orchestration tool that automates container deployment, scaling, and management across multiple nodes. So simply you can say Kubernetes is further like working, you can say, after the Docker it's required, you can say, for the deployment purposes, for scaling and managing the applications on multiple nodes throughout the network. Okay. In a distributed network, you can say it will be working. And when we talk about cloud computing, in the cloud computing, anyways, the distributed networking architecture is there, definitely, because we are able to access the things from anywhere, anytime. Okay. Now, simply let's talk about their features. So simply the features which we are going to talk about, that is going to be the OS overhead, speed, resource usage, and scalability. So on these four features, I will be comparing the virtual machines and the containers. So when we talk about the OS overhead, so virtual machines require a full operating system per virtual machine. Full operating system per virtual machine is required. Whereas in the containers, shared host operating system kernels are there. When we talk about the speed, virtual machine, slower boot time. Okay, the boot up time is slower as compared to the container, because containers are faster at the startup. Then the resource usage, if we talk about, so virtual machines like more resource intensive, and when we talk about the container, lightweighted. Containers are lightweighted, containers are fast, containers are having the shared host operating system. That is the reason why they are fast and lightweighted. Then when we talk about the scalability, so in the virtual machine, it is harder to scale dynamically, whereas in the container, it is easier to scale and deploy. So you can just take a look at it, the comparison. After that, let's talk about the cloud storage and database management. That is going to be the second topic in this particular. So When we talk about the cloud storage and database management, so although this is going to be in very, very detail because the DBMS, some are like advanced DBMS features also we will be discussing. Storage preferences also we will be discussing further. Even the AWS will be in the complete detailed manner. So when we talk about the cloud storage and database management, so storage types in the cloud are object storage, block storage, file storage. Okay, so and SQL and no SQL. So simply that I will talk about later. Before that, I will talk about the object storage, block storage, and file storage. So when we talk about AWS S3, this is actually something inside, you can say, AWS. Like simply the what is AWS? AWS is Amazon Web Services. There we are having the concept of S3. So the S3 is what? It is like object storage. Okay, it stores data as objects with metadata and unique identifiers and used for large scale unstructured data like images and videos. When we talk about the block storage, so EBS, okay, EBS is again there in the AWS. So it provides low latency, high performance storage, like similar to the hard drives, and it is ideal for databases and applications requiring fast read write speeds. So block storage is for that, low latency, high performance. Okay, then when we talk about the file storage, so it is managed by, you can say, like managed file system like Amazon EFS, Google Cloud File Storage, and Azure File Support, access, shared access it is having the file storage with file hierarchy structure. So hierarchical structure, top bottom approach kind of is there when we talk about the file storage system. So these are the different storage types in the cloud. After that, SQL and NoSQL is there. So SQL is simply the relational database management. You can say RDBMS concept is there. So simply like if you must have heard about the like MySQL and all, that is concept of SQL. Oracle is also giving the concept of SQL. When you talk about NoSQL in the, you can say, normal scenarios in the without cloud when you are working that time, simply as MySQL, Oracle kind of stuff you can use for the SQL. For the NoSQL, MongoDB is there. Okay. So when we talk about SQL, that is the structured query language, which is actually present in the relational database management, which is known as RDBMS. So structured data with flexible schemas. Schemas are the tables, database tables. Asset compliance, asset properties are there. Okay. So simply, for example, in the case of the cloud, Amazon RDS and Google Cloud SQL is present for the RDBMS, you can say relational database management system. Okay. Then NoSQL, when we talk about, so non-relational databases are there, and it is having the flexible schema for semi-structured or unstructured data, great for big data. Okay, a huge amount of data you are having. So MongoDB, Atlas can be used, DynamoDB can be used. Okay, and I will be telling all about it. Then simply, if we compare and contrast the SQL and NoSQL, because it is quite interesting and important anyhow. So simply, when we talk about the features, so schema, transaction, scalability, and use cases, I will be comparing. In the SQL, which is known as the relational, the schema is fixed. The rows, tables you define directly. In the non-relational, NoSQL, it is flexible. It is a document-based architecture actually. JSON concept is there. JSON concept is there in the NoSQL. Then simply the transactions are having the strong asset compliance in the SQL, whereas in the NoSQL it is eventual and consistency is there. Eventual consistency is there. Then when we talk about the scalability, so vertical, the SQL is vertical. Okay, simply scale up. When we talk about NoSQL, it is horizontal. It scales out. Okay, these are the like terminologies you can say. When we talk about the use cases, so for the SQL, like banking, ERP, CRM, that is the content management system, sorry, customer relationship management, CRM. And for the NoSQL, social media, IoT, big data, the MongoDB and all is getting used there. So simply the social media, IoT, big data is example, the use cases of the NoSQL. Then the next thing which comes into the picture, that is going to be the serverless computing and edge computing. Serverless computing and edge computing, very, very important stuff, very important concept which I am discussing with you. So simply when we talk about the serverless computing, how serverless computing eliminates infrastructure management. That is the thing which comes into the picture. That why to use serverless when we are already having servers? So what is the meaning of serverless? What is the serverless computing? How serverless computing eliminates infrastructure management? When we talk about this, serverless computing allows developers to deploy applications without managing servers or infrastructure. When we talk about serverless, so you do not have to simply deploy. Okay, it is serverless actually, serverless. The cloud provider automatically handle scaling, resource allocation, and maintenance. Serverless computing is a cloud-based model for building and running application without managing servers. You don't have to manage the servers. And in this model, a cloud service provider, that is also known as the CSP, manages the infrastructure. So developers can focus on writing code. Like you can say how it works. Developers write and deploy code to the cloud. The CSP, that is the cloud service provider, provisions, scales, and maintains the infrastructure. And developers pay for the resources they use, not for the servers themselves. And when we talk about the benefits of the serverless computing, you can say, so it is cost effective, scalable, flexible. Okay. And if we talk about the use cases of the serverless computing, so simply RESTful APIs, microservice support, high volume background processes, and backend task for mobile apps and websites is serverless actually. IoT data processing is serverless. Event triggered computing is serverless. So, so simply AWS Lambda is an example. AWS Lambda, an event-driven serverless computing platform, it is for from the Amazon Web Services. So AWS Lambda runs functions in response to triggers. For example, HTTP, that is the Hypertext Transfer Protocol request, database changes. For that is there, it is there. Google Cloud Functions, like similar to the Lambda, there is like Google Cloud Functions. It like used for event-driven applications. There is one Amplify framework also, an open source framework for building cloud-enabled mobile and web application. Amplify framework is the name there. Then when we talk about the edge computing, okay, like we have talked about the serverless. Now, if I talk about the edge computing, it is really very buzz term, you can say. So in the edge computing, the cloud computing is there. So cloud computing and edge computing are the two terms. Edge computing is basically a technology that processes and stores data close to the users or devices that you can say generates it. Okay, who is generating it to them, near to them, it is stored instead of a remote data centers. Like in edge computing, simply you can say it is the technology that processes the data close to the user or the device, and it's useful for the situations that require real-time data processing and analysis. Okay, when we talk about cloud computing, it processes the data in centralized data centers suitable for large scale applications. Whereas when we talk about the edge computing, it processes the data closer to the user or device. For example, IoT devices, smart sensors, to reduce latency. So here you can see the comparative study of cloud computing and edge computing. The features which we are comparing are processing location, latency, and use case. When you talk about the processing location, so in the cloud computing, it is centralized. Data centers are there, central data centers are there, you can say. In the edge computing, distributed near the data source. Okay, in the edge computing. Then when we talk about the latency in the cloud computing, it is high. When we talk about the edge computing, so it is low. Latency is low. So latency, what is latency actually? Latency is the delay. Okay, latency is the delay between when an action is performed and when it reached to its destination. Okay, when some action has taken place and when it reached to its destination, between them, whatever time is getting taken. So simply that is the delay. It is known as the latency. It is simply a networking term. I hope you are already knowing it. Then when we talk about the use cases, so use cases are simply the web apps, SaaS platform, simply the software as a service models I have talked about with you. In the edge computing, the use case could be the IoT, autonomous vehicles, because there also the real time data is required when we talk about the autonomous vehicles. Okay, so this is a brief comparative study of the cloud computing and edge computing. So I hope whatever I've discussed till now, that much is clear to you. In case you have any query, you can tell. Our today's session topic is cloud computing with AWS. So it's important to firstly understand about cloud computing. Let's understand about why cloud computing was needed. What was the problem that we had that cloud computing solved? And since then, it took over the market. Here on the left, we have an owner of a business and he wants to set up an DC or have an IT infrastructure for his company. So he called Paul, an IT educated person in his company, and consulted him about how to go for setting up an IT infrastructure. Now, Paul is the kind of person who keeps himself updated about what's happening in the IT industry, and he frequently goes through learning about the recent technologies. So, Paul suggested why not to set up the environment in the cloud, but his manager was not sure about what is cloud, and more than trying to understand what cloud is, he was curious, you can say, about the benefits of the cloud over having a DC, that is the domain controller, locally. So Paul started to explain the very same thing that I am going to explain you now. Let's start with the expenditure or the billing mode, like a billing model with cloud. So the billing model is pay as you go type in the cloud. Okay, meaning we use less and pay less, and we use more and we pay less per unit. On the other hand, in the on premises, we can't expect that. Like we pay everything upfront, and there is an additional operating cost, and it never lets us to dynamically scale. In on premises, a lot of space is required for sitting the servers, but in the cloud, not such a space required. There is no requirement of such spaces for the organization. In on premises, we also need to dedicate, like have a dedicated team to manage the hardware and software. But in the cloud, no such dedicated team is needed. For most of the services, they all get managed by the provider itself. And even if we need to manage them, the provider gives us options to manage them through the console, which is a lot simpler than managing directly from the device. In the on premises, we need to admit the fact that their security is poor due to the cost involved in procuring the hardware and the software to provide the security. But in the cloud, the security standards are high due to the investments the providers have done to secure the data and to meet the compliance, you can say. In the traditional domain controller, they will like generally be less focused on the data recovery and kind of a settle for, you can say, when it comes to data recovery due to the cost involved, and the like efforts involved in replicating the data. And even if we set up an high performing data replication, a lot more can be done in the cloud for the same cost. The on-premises environment lacks the flexibility needed today. If I need to restructure the IT for the new age, you can say business needs, then the on-premises is not so friendly for such changes. But in the cloud, I can easily undo or tear down an environment, or migrate to the new environment and tear down the old environment in few button clicks. Now, looking at the number and the frequency of the releases that happen, scheduling updates would be a full-time job. But with cloud, the updates happen automatically. In on premises, if I am working with a team that is spread across the globe, you can say, working with them is unison and sharing the data is tedious work. But with the cloud, there are a lot of tools and technologies put together that make it easier to share the data with other members in the team or with the new prospective customers. And I will be working, like you can say, with the who is present across the world or other side of the globe. So in on-premises, the data will be present inside the domain controller or inside the on-premises DC. And even a valid user trying to access the data from outside the organization is a tough task. But with the cloud, as long as someone is having the internet providing, the person access is just a few mouse clicks away, you can say. It's quite simple in the cloud. After all this explanation and comparisons and talking about benefits, Paul's manager was fully enlightened and wants to have his IT environment in the cloud itself. But Paul is not done yet, and he took his manager through another level of discussion about the cloud, just like I am going to take you now. So let's talk about what is cloud computing. Now, cloud computing is the ability to deliver on demand computing services over the internet, and that too as like pay as you go basis. Now you might think, well, what does that mean? So let me explain. With the cloud, rather than managing files on local storage devices, cloud computing makes it possible to save them over the internet and access them from the internet. So I can be a mobile person in a moving from one place to another, but I can access the storage from the internet because you can say it's in the internet, it's in on the cloud. And if I want to give access to somebody else, it is easy for me to give the access to them as long as they have the internet connection available with them. Now let's move further and talk about or get understanding on the types of cloud computing. I hope whatever I have discussed till now, that much is clear. So let's move further with the types of cloud computing. We can categorize the different types of cloud computing based on two wide categories. One being a deployment model and the other one is service model. Okay, the deployment model and the service model. So let's talk about the deployment model first. Deployment model is categorized into three types. First one is public and then private and then hybrid cloud. In other words, public cloud, private cloud, and hybrid cloud. So it will be easy for me to explain, and also it will be easy for you to understand if I walk you through this example. So consider the different types of vehicles we use to commute from one place to another. For example, if I want to travel, I can pick a bus which is accessible to anyone. I get in and I pay for the seat that I occupy, and I pay for the time that I will be traveling in it, and I'm done. Like, cost is very less here. A similar kind of thing happens in the public cloud. I pay only for the resources that I use, and I pay for how long I use it. If I use less, I pay less. If I use more, I pay more for that month simply. On the other hand, private cloud is like buying your own car and using it for commuting purpose. Here I pay a huge amount upfront, and it is all owned by me, like only by me. I do not pay for it in the ideal fashion, but completely and all of friends, the cost is very high, very huge here. When we talk about owning a car, a private car, so the cost is quite high here. And thirdly, if I want the best of both types, like the comfort of the own car and still do not want to pay all the upfronts, otherwise, want only to pay for the time that I use the service, I can rent a car. Similarly, I can have it in the hybrid environment, meaning if I already have a DC, the domain controller, I can integrate it with the cloud and use both the domain controller, and that would be and hybrid environment, you can say. So, all right, that was good of learning till now. I hope everything is clear. So, let's summarize the types of cloud based on deployment model, as we are now about like the public cloud. Public cloud is a cloud infrastructure that's made available to the general public over the internet, and it is owned by the cloud provider. Some of the major players of the cloud provider are AWS, Microsoft Azure, IBM, Blue Cloud, and Sun Cloud are also there. Then the private cloud. Now, this cloud infrastructure is exclusively operated by a single organization, and it can be managed by organizations or third party, and may exist on like on premises or off premises, does not matter. But the point here is that like this is exclusively operated for a single organization, and some companies that provide private cloud as AWS and VMware are the examples, you can say. Then hybrid cloud is the best of both public and private cloud. For example, the federal agency that they opt for private clouds for storing and deploying personal data, and they use public cloud to share the non-sensitive data with the general public or with other government departments, you can say. So now let's talk about the different cloud based on the service model. What are the different cloud based on the service model? So if we need to categorize them broadly, we can categorize them as infrastructure as a service, IaaS, that is platform as a service, that is PaaS, or software as a service, that is SaaS. Now at this moment you could be like this person Sam, okay, thinking that I thought you have done categorizing the cloud. Now you are going to talk about the three more categories. Which one should I pick now? Like, which should be the best option? How you will analyze, how you will understand that what is the correct thing to be chosen according to the requirement? How you will analyze? Well, let me explain. If all that you want is just the VM, that is the virtual machine, and you have all the expertise to install the software on the top of it and make it work, then go for the IaaS. Okay, that is the infrastructure as a service. If you only want a platform or an infrastructure to like a program or an interface to upload a program and make run, so the PaaS, that is the platform as a service. And if all that you want is a finished product hosted in the cloud and be able to access it to the internet, then go for the SaaS, that is SaaS. Here you get the username and password for an application, and you can begin to customize the application based on your needs. All right. So let's talk about IaaS in a bit more detail. So IaaS gives basic computing infra. It's based on a pay for what you use model, and some of the cloud providers who are the big players in it are AWS, Azure, and Google Cloud. And here the users generally will be the IT administrators. Then in the past, that is the PaaS, that is the platform as a service. So in past, the providers gives you the platform or a runtime environment for developing, testing, and managing applications. And it's platform ready. You buy the platform, you upload code, and you start working on it. So it allows the software developers to deploy applications without running the underlying infrastructure. And as you might have guessed by now, the interesting candidates who would be using PaaS is software developers, definitely. Software developers are the person or the people who use this kind of service. And in SaaS, everything is managed by the vendor, be it be the hardware or the software, it's managed by the vendor, and we pay for the service, and we pay for it through a pay as you go subscription model. And as you might have guessed, simply the end user would be the customers itself. Like we use the PPT, the presentation, and Google products. No, in the Google we are having Google Sheets and all. So those all like Gmail and all are simply the example of SaaS. All right, let's put everything together in the same page and compare and contrast the types of service models. In this chart, it explains the difference between the four models, starting from on premises to IaaS, then PaaS, and then SaaS. So it is self explanatory that the resources managed by us are huge in on premises and little in the IaaS, and further less or reduced in the PaaS, and nothing to manage when it comes to the SaaS. So let me also explain the different types of cloud service through an example. Like this, let's say that you are planning to bake one cake yourself. Now let's look at the options you can have. You can make all the ingredients by yourself, be the flour, butter, and put together and bake the whole thing yourself using your own oven, pan, like the needed water and the rest of the things. You get the idea, right? Everything is yours, and that's on premises, like all that you use is owned by you and nothing is managed by the vendor in the case of the on premises. Okay, so simply in the on premises you are having everything to be managed by you, and the vendor is doing nothing, everything you have to use by yourself and you have to prepare the stuff. The other option you can have is to buy the ingredients and mix and bake the cake yourself. And now this would be like IaaS. Here the infra is managed by the provider and we get to use it and customize it the way we want it. Here the cloud service isn't shared responsibility. The other option you still have on hand is simply pick up the phone and order the cake. Now this is a lot simpler, like than rest of the options which we discussed so far. It's simply picking the phone and ordering the cake, pay for it when it arrives, and like it's simple. And when it reaches home, you will have to arrange the table, garnish the cake, and that's it needed. And then enjoy the cake. And this is the same which happens in the past. Just get the platform in which you would run your code and upload your code and start running your applications. Here, you and the vendor still share the responsibilities. Now, you still have one more option left. That is simply go out and dine. And this is a lot simpler than that is required. No, it is requiring no effort from us at all. And you buy the fully furnished, fully finished and garnished cake and pay for it and walk out simply. No responsibility on making the cake. It's the same way with the SaaS. We buy the finished product and we pay for the finished application. Okay, so I hope whatever I have discussed till now that much must be clear. So the next thing which comes into the picture, that is simply the different cloud providers, and it is a quite detailed topic. So I will be taking care of it afterwards. So let's talk about the different cloud providers. Like Amazon Web Service, that is AWS, is a cloud computing service provided by Amazon. It provides a mix of infrastructure as a service, that is IaaS, platform as a service, that is PaaS, and packaged software as a service, that is called SaaS offering, SaaS. Then Microsoft Azure, formerly known as the Windows Azure, is a cloud computing service by Microsoft, and it sort of specializes in using cloud for building, testing, deploying, and managing the applications to the service throughout the globe network that Microsoft manages. It also provides software as a service, platform as a service, infrastructure as a service, and it supports a lot of different programming languages and tools and frameworks, including both the Microsoft and the third party software systems, softwares and systems. IBM Cloud is a cloud computing service offered by IBM, and IBM Cloud includes infrastructure as a service, software as a service, platform as a service. Now the difference here is that it offer through public, private, and hybrid cloud delivery models. Then the VMware, on the other hand, is a subsidiary of Dell Technologies, and it provides cloud computing and platform virtualization software and the services. It was the first commercial successful company to virtualize the x86 architecture. Then the Google Cloud Platform, on the other hand, is offered by Google. It's a suite of cloud computing service that run on the same infrastructure as the Google uses internally for its end user. Okay, which Google uses for its end user products, such as the Google search and the YouTube we are familiar with. Alongside a set of managed tools is also provided, it provides cloud services including computing services, data storage services, data analytical tools, analytics services, and machine learning services. Then the Digital Ocean, on the other hand, is headquartered in the New York City with data centers worldwide. And DigitalOcean provides developers cloud services that help to deploy and scale applications that run simultaneously on the multiple computers. As of January 2018, DigitalOcean was the third largest hosting company in the world in the terms of web facing computers. Now let's talk about cloud computing in AWS. So Amazon Web Service, AWS, is a cloud computing service provided by Amazon. As these services are accessible over the internet, and because AWS provide infrastructure as a service, it's a flagship offering. We can create and deploy any type of application in the cloud on top of the is the Amazon providers. And the best part here is the subscription is pay as you go type. You use less and pay less, and only for what you have used. You use more and you still pay less, pay per unit for the service used by you can say, and it is attractive. Now let's talk about the life cycle of the cloud computing solution. So the very first thing in the life cycle of a cloud computing solution is to get a proper understanding of the requirement. I didn't say that get the requirement, but I said that get a proper understanding of the requirement. And it is very vital because only then we will be able to properly pick up the right service offering, like service offered by the provider itself. Then getting a sound understanding is the next thing which would be required. It would define the hardware, meaning choose the compute service that will provide the right support when you can resize the compute capacity in the cloud to run application programs. And getting a sound understanding of the requirement helps in picking the right hardware. One size does not fit all, and there are different services and hardwares for different needs you might have. Like EC2, if you are looking for it, and Lambda is if you are looking for the serverless computing, and ECS that provides container rest service. So there are a lot of hardware available to pick up the right hardware that suits your requirement. The third thing is to define storage. Choose the appropriate storage service where you can back up your data, and a separate storage service where you can archive your data locally within the cloud from the internet. And choose the appropriate storage, that is the one separately for the backup called S3. And there is one separately for the archival also, that is known as Glacier. So, knowing the difference between them really helps in picking up the right service for the right kind of need, you can say. Then define the network. So, define the network that securely delivers data, video, and applications. Define and identify the network service properly. For example, VPC for network, route S3 for DNS, and direct connection for private peer to peer line from your office to the AWS data center. Then define the security. set up the right security service, IAM for authentication and authorization, and KMS for the data encryption. And like at rest, so simply there variety of security products available. We got to pick the right one that suits for our need. And there are variety of like deployment and automation, and monitoring tools that you can pick from. For example, CloudWatch is for monitoring, like auto scaling is for being elastic, and cloud formation is to define the management process and tools. You can have complete control on your cloud environment if you define the management tools which monitor and like your AWS resources and are the custom applications running on the AWS platform. So there are a variety of deployment automation and monitoring tools. You can pick from them like CloudWatch for monitoring, auto scaling or automation, and the Cloud Formation for deployment. So knowing them will help you to in defining the life cycle of the cloud computing solution properly. And similarly, there are a lot of tools for the testing process also. So testing a process like Code Star and code build and code pipeline. These are tools with which you can build a test and deploy and simply code quickly. And finally, once everything is set and done, click the analytics service for the analyzing and visualizing the data using the analytics service where we can start querying the data instantly and get a result. Now, if you want to visually view the happenings in your environment, you can pick Atena. And other tools for analytics are AMR, and which is Elastic Map Reduce, and their cloud search. Now, after this, I would like to talk about the utility computing. So, what cloud computing is today? Like what cloud computing is today? So, yet the ability for you to access it, and like IT infrastructure, which is like compute, storage, so databases, load balances, networking, on demand, pay as you go, like uniform in available fashion over the APIs. It takes away the hard work from providing IT infrastructure and making it available to you where you are. Okay, so many like services it is providing. So today, AWS has over 150 plus services that range from compute, storage, network, databases, analytics, application services, deployment and management, artificial intelligence, IoT, mobile, security, hybrid and enterprise architectures. And we are able to service, or like you can say, we are having the opportunity to use all of this just at an electricity grid. So think of it as it is the ability to tap into infrastructure anywhere across the world. So AWS, like today, AWS has global infrastructure spanning across 18 separate regions with 55 availability zones and over 100 plus edge locations. You have the ability to, like with one single AWS account, to access all these global regions and deploy infrastructure across multiple geographies in the world. And this also gives you the benefit to deploy applications to locations which are closest to your to your end users, help reduce latency, and to also meet regional specific regularity and compliance requirements. So you have the ability to choose the region and the data centers and the infrastructure that you can deploy. That also means that you were compliant with those regulatory laws, and also AWS does not move data across from one region to another. It does not move the data automatically without the permission, or you can say acknowledgement of the user. The data is not moved automatically. So when you when you deploy data or infrastructure in a particular region, it stays within the same region. So, like, really, what are the benefits of cloud computing? You have the ability to move away from operational or move to an operational and variable cost. You basically have the ability to trade capital expenditure for variable expenses. So instead of having to invest heavily in data centers and servers, and before like how you are going to use them, you can manage them before that. You can pay for what you consume and the computing resources, and you pay only for how much you really consume. You also benefit from economies of scale. So by using cloud computing, you can achieve lower variable costs than you can like get on your own. And because you use because usage from hundreds and thousands of like customers are aggregated in the cloud providers like assets, AWS can achieve higher economies of scale, which translates into lower pay like you go prices, you can say pay as you go prices. You do not have to guess capacity. So the ability for you to deploy infrastructure on demand when you need, where you need, eliminates and the need for you to guess capacity based on what your business is going to be. So when you have a capacity decision to make, you could lock into the console and you could deploy as much infrastructure as it is required. And with this, the issues of guessing capacity are commonly eliminated. It also helps you increase speed, agility, and innovation. So, in the cloud computing environment, new IT resources are only ever a click away, which means you reduce the time it takes to make those resources available to your developers from weeks to just minutes. This results in dramatic increase in agility for your organizations, since the cost and the time it takes to experiment and deploy is significantly lower. You can stop spending money on running and maintaining data centers. Like the focus is to differentiate between differentiate your business, not the infrastructure, and allow AWS to remove the undifferentiated heavy lifting. So that allows you to focus on what's critical and crucial to your business rather than deploying infrastructure, deploying service racking, and stacking and managing the data centers. And the last one is the ability to grow global in minutes. You could easily deploy the application in minutes, like multiple regions across the world, and just few clicks away. This means you have the ability to provide a lower latency and better customer experience for your customers at a really low cost. So, why do people choose AWS? To dive into that a little bit, as we have covered, this is the earlier slide. The one of the primary reasons is the breadth and depth of the services today. Like AWS is having over 150 plus services across the multiple domain analytics, multiple regions they are having domain analytics, app services, mobile development, security, and just pure infrastructure as a service as well, which could be your compute storage, network, and databases. With the ability to choose individual services and run individual services or combine multiple services to create an entire suite of applications, the choice completely resides with you. Also, customers really choose AWS because of the pace at which AWS innovates. AWS offers us over 129 fully featured services, and over the last 3 years, AWS has launched more than 4,500 to 4,600 new features since the inception in 2006. And till date, AWS has launched 300 new features and services as the March 31st, you can say. So AWS is continuously improving a security. So AWS provides the same familiar approaches to security that companies have been using for decades, with increasing visibility, control, and auditability. So the key area here I want to cover is about visibility, control, and auditability. So visibility, that would mean that AWS provides us the ability to look into our infrastructure in a transparent manner. This level of transparency is extremely difficult, if not possible, to achieve on premises. So AWS has multiple services such as AWS Cloud Trial and Cloud Watch, so which allows you to get deep insights into your infrastructure. You also have the ability to control where your data is residing and how your data really moves about. AWS takes geographic location or data extremely seriously. When you create AWS virtual machines, that is VM, or you create or store any data on the AWS, you must specify where it resides, and once it's created, only you can move that data. So AWS will never change the geographical location of your data on behalf of a customer. It also has something that's called a shared responsibility model. So AWS is simply responsible for the security of the cloud, while we as a customer are responsible for security in the cloud, which essentially means that AWS takes care of the underlying infrastructure, the data centers, the servers, the storage, and everything around the security up to the hypervisor. As we as a customer are responsible for our data that sits in the cloud, and we are responsible for encrypting the data, for how access is given to those bad data. So AWS share responsibility model provides clear ownership of the security and implementation. And AWS maintain the security of our infrastructure to maintain the security of the workloads also. And with free end-to-end encryption, customers can easily maintain data security across infrastructure auditability with a broad portfolio of certifications. So AWS works daily to ensure that workloads are both regulated and unregulated, compliant with industry standards. So there are many third-party validations in the security certifications that are available. For example, SOC 1, SOC 2, PCI, HIPAA, and compliance certifications such as DDPR as well. So you're better off with the AWS with your environment, because nearly 60% of the cloud service providers really agreed that AWS provides better security than their own centers, you can say. Okay. So apart from the security, one another primary reason that the customers choose AWS is the expensive partner ecosystem. So AWS has the largest and deepest partner ecosystem in the cloud and continues to grow at a rapid pace. It's very likely that like then any system integrator or independent software vendor partner of your choice are already partners with the AWS, and having this support in place makes it more easier for you to adopt shift work, generate new business by moving on to the cloud. AWS also has a marketplace which allows customers to directly purchase and deploy business applications into their AWS environment. AWS has a number of customers in India also, and a few of key startup customers are here. AWS has got large aggregates such as Ola, Zomato, Credit Mantri, and Freshdesk, all running large scale infrastructure on AWS. And not only just a startup, but a lot of the SaaS provider also leverage AWS. So we already talked about Freshworks, but traditionally SaaS providers such as Ramco and Excelsoft are new vendors such as um, mm, Mantina, you can say Dhruva, but it's just doesn't limit to SaaS vendors as well. AWS have a large portfolio of enterprise that are running mission critical workloads on AWS, such as NDTV, Tata Sky, Jubilant, Viper, Cognizant, all running mission critical workloads on AWS. Okay, so simply to give you a little overview of the AWS service, it's important to talk about how its infrastructure is deployed. So AWS has three concepts: region availability zone and context context delivery network CDN. Okay. So a region is essentially a collection of two or more availability zones in a specific geographic area. An availability zone is an isolated collection of AWS resources. These are distinct locations. Within an AWS region, they are engineered to be isolated from failures, and low latency availability zones within a region are connected through low latency links. And remember that all the availability zones are relatively close to each other geographically. They still keep isolated from each other. Now, unlike availability zones, regions are completely independent from each other. Apart from this, AWS has also has its content delivery network, and we talked about the 100 plus edge locations that we have in the AWS. So across the world, these edge locations host robust content delivery network that can be used to deliver static websites, dynamic content, and streaming content. Request based content. Requests for content are automatically routed to the nearest edge locations. So content is delivered with the best possible performance you have, and you can say the ability to choose which region your application and which availability zone your infrastructure resides in as well. Okay, so to get a little more in depth of the services that AWS offer, it's important to know the fundamentals, which is compute, storage, and network. And under compute, AWS has three basic services: Amazon, like AWS Amazon EC2, which is a realistic virtual server on the cloud, which comes in multiple flavors depending on the type of the workload that you would like to run. And it has got over seven families of virtual machines cutting across multiple use cases. So if you have got a requirement for a really RAM intensive work, so it has got machines that meet that criteria. It also have machines that allow you to do a lot of HPC and machine learning on the AWS as well. And these are machines that allow you to add in FPGAs so that you can train your machine learning algorithms as well. Another key important feature is the elasticity of the cloud, and that is really achieved by using auto scaling, the ability to automatically scale the capacity as your load increases without having to worry about how I am going to guess the capacity. So auto scaling allows you to automatically add in more infrastructure as your load increases, and as the load decreases you could automatically also remove that infrastructure. And the third key component is the load balancer. The load balancers allow for the dynamic distribution of traffic across your multiple server. Load balancers also play in an important function in managing how much your infrastructure can scale out to and scale in. And load balancers also allow you to do a number of other things. AWS has got three types of balancers even, simply the elastic load balancer, which is in L4, network load balancer, which is in L4 again, and simply application load balancer, which is available in L7. So depending on the use case, you could choose any type of the load balancer. Now, AWS has got multiple storage services as well. So the most basic and fundamental storage service is Amazon EBS, which is block storage that we use with the conjunction with the virtual machines, you can say. Now, this is in almost skin to the heart that it resides on your physical servers or say on your laptops. This is where the storage in which you will be storing all your application data, and the data has to be persistent. Amazon S3 is an internet scale storage that can be accessed via the APIs, and it's identically ideally used to store any kind of object. It could be images, videos, files, snapshots, or binary files even. Amazon Glacier is a long-term archival system. So long-term archiving storage and backup solution which can store images, videos, files, binaries, and snapshots, like any kind of file, multimedia. It's a cold storage and is designed to be a cold storage with low retrieval times. Also, there's Amazon Storage Gateway, which allows you to integrate all of these cloud-based storage options with your on-premises storage. The third component is networking and CDN. So the fundamental or co-fundamental concept in the networking is something called Amazon VPC, which is called Virtual Private Cloud. And this is essentially in your private isolated sections in the AWS cloud. This allows you to create your own networking rules, your own firewall rules, and then isolate your infrastructure across this. It is your private isolated section in the in the public AWS cloud. You could do exactly what you do on the on premises today, or in any other infrastructure environment, or you can say Amazon using the VPCs. So we talked about the Amazon Cloud Front. We talked about the content delivery network, which is nothing but the Amazon Cloud Front. The ability for you to distribute content globally by the 100 plus edge locations. And it has also got Amazon Root S3, which is a domain name, 53 actually, which is a domain name service allowing you to manage all your domains, also allowing you to do multiple regional deployment, like a regional deployed region based deployment, and do innovative things such as cross regional DR as well. Okay, so till here I will be keeping because there is much more which I will be discussing further, not right now. We shall cover all the remaining further. I hope this much is clear. Okay, so we are going to talk about the overview of AWS services, and simply with the previous sessions, we have at least discussed that what are the what is the meaning of cloud computing, why do we use cloud computing, what are the better aspects of cloud computing, why we should use cloud computing as compared to on premises, what are the different types, and those things we have discussed. And today we are going to talk about the overview of AWS services. So to get a little more in depth of the AWS services, it offers like important fundamentals. This also actually I have discussed. No, this I have not discussed. This only this much I have discussed, but I will give you a recap of it. Okay. So simply this was a region availability. So AWS has three concepts: region availability zone and a content delivery network. This I have discussed in the previous session, but I am giving you an overview in a different manner. Okay, in a different manner. So region is essentially a collection of two or more availability zones in a specific geographic location. And you can say an availability zone is an isolated collection of AWS resources, and these are distinct locations. Within an AWS region, they are engineered to be isolated from failures or low latency availability zones. Within a region, like you can say, they are connected through low latency links. And always remember that all the availability zones are relatively close to each other. Geographically, they still keep isolated. They are kept isolated from each other. And like you can say, unlike the availability zones, regions are completely independent from each other. Okay, when we talk about the regions, they are completely independent. Apart from this, AWS also has its content delivery network, and we talked about the 100 plus edge locations that we have across the world. So these edge locations host our robust content delivery network that can be simply like we can use them in the delivering of the static website, dynamic content, and streaming content request for the content automatically, and routed to the nearest edge location. So content is delivered with the best possible performance. You have the ability to choose which region your application and which ability zone your infrastructure resides in as well. Okay, now to get a little more in depth of the services that AWS offer, it's also important to know the fundamental, which is compute, storage, and network. Under the compute, AWS has three basic services of, you can say, AWS Amazon EC2, which is a realistic virtual server on the cloud, which comes in multiple flavor depending on the type of workload that you would like to run actually. And it has got over 7 families or virtual machines cutting across multiple use cases. So if you have got a requirement for a really RAM incentive workload, it has got machines that meet the criteria. And it also have machines that allow you to do a lot of HPC and machine learning on the AWS as well. And there are machines that allow you to add the FPGAs so you can train your machine learning algorithms as well. Another key important feature is the elasticity of the cloud, and that is really achieved by using auto scaling, the ability to automatically scale the capacity as your load increases without having no worry about how I am going to guess the capacity. So the auto scaling allows you to automatically add more infrastructure as your load increases, as like you are increasing the load onto it, and as your load decreases. So you could automatically also remove the infrastructure. And the third key component is the load balances. The load balances allow for dynamic distribution of traffic across your multiple servers. And the load balancers also play an important function in managing how much your infrastructure can scale out and scale in. And load balancers also allow you to do a number of things. AWS has got simply three types of load balancers: the elastic load balancer, which is L4, network load balancer, which is in L4 again, and an application load balancer, which is in L7. Okay, so depending on the use case, you could choose any type of load balancers. Now, AWS has got multiple storage services as well. So, the most basic fundamental storage service in Amazon is EBS, which is block storage that we use with the conjunction with our virtual machines, you can say. Now, this is, you can say, almost skin to the heart, and that resides on your physical servers or say your laptops. This is where, like, this is the storage in which you will store all your application data, or that has to be persistent. And Amazon S3 is an interesting model. It is an internet scale storage that can be accessed via the APIs, like the application programming interfaces, and it's ideally used to store and kind of object it could be, like imagine videos, files, snapshots, or binary files. Amazon Glacier, that is the third one here on the screen, you can see. Amazon Glacier is a long-term archiving, storage, and backup solution which can store images, videos, binary files, and snapshots. And it's a cold storage, and is designed to be a cold storage for low retrieval times. Also, there Amazon Storage Gateway, which allows you to integrate all the cloud-based storage options and your on-premises storage. Actually, are you all getting the idea what I'm talking about? Everybody answer. Storing of data in different manner. Yes. And yes, in the previous session, I asked you all to revise and come. Have you done that? Because I don't want these sessions to be so conceptual, no interaction. Make sure that you interact. Interaction is very necessary in these sessions. If I ask you anything, so please try to answer it. Either it is right or wrong, that does not make a difference. But I want you to answer. Okay, how many of you are prepared today? If I ask anything from the previous stuff, from the previous things which we have discussed. Okay, so simply nobody is here who is going to answer. I can understand that you all are here only for certificates. You are not here for learning. You all people are here only for certificate. And you know this thing. If you are not able to submit your assignments and you are not performing well, so how you will be getting the certificate? Okay, but I am talking to all others also who are present here since the starting sessions. Whenever I ask something, nobody answers. In the first session only, I have informed you this thing that you have to be attentive, you have to answer me. I was about to give you additional learning material related to Python and all. So, because your projects and all will be related to Python. So, in the alternative session, you have to do those assignments also. In this parallel live classes, I will be discussing the cloud. In the alternative, you will be learning the Python. The gap which you are having, I will share with you all the stuff. So AWS has got database services, and there are three ways you could really run the database on the AWS. You could run databases on plain vanilla virtual machines by deploying a virtual machine and then installing the database engine and managing it yourself. Or you could use the Amazon RDS, which is like you can say used for managing the relational database service. Today, Amazon RDS offers six database engines: Oracle, Postgre, MySQL, SQL Server, MariaDB, and all. Also, the AWS like has the Amazon Dynamo, that is DynamoDB, which of like it is managed by NoSQL database services. So NoSQL database services is there in the DynamoDB. Then Amazon Elastic Cache, which is like in memory caching service. After that, like there are also big data services that we have to offer: Amazon EMR, Elastic Map Reduce, which is the Elastic Map Reduce. It is nothing but a hosted Hadoop framework. So Hadoop is Java framework, and it is simply hosted Hadoop framework, completely managed or simply by the AWS. So you don't have to worry about managing and creating a Hadoop cluster on AWS. When we talk about the Hadoop framework, let me tell you something about the Hadoop framework also. How many of you have heard about Hadoop framework? Simply, Apache Hadoop is an open source framework that is used to efficiently store and process large data sets ranging in size from gigabytes to the petabytes of data. Instead of using one large computer to store and process the data, Hadoop allows clustering multiple computers to analyze the massive data set in the parallel. It is open source based on Java that manages the storage and processes the large amount of data for the applications in the cluster format. Okay, it helps to create the cluster. So Hadoop uses distributed storage and parallel processing to handle big data and analytics job. and breaking workload down into smaller workloads that can be run at the same time. Okay, now AWS takes care of managing the entire cluster for us. We just have to decide what size of cluster we do need and how many nodes we need in that cluster, so that we can choose. Then the size will be decided, and the managing is basically done by the AWS. And AWS has also got Amazon Cloud Search, which is a managed search service used for the managing the search service, and Amazon Redshift, which is a petabyte scale data warehouse service. Petabyte scale data warehouse service, it is Amazon Redshift. After that, Amazon has a number of tools and around the development in the administration as well. So Amazon CloudWatch is the tool that allows you to monitor and view your AWS resources. The AWS identity and access management, which manages user groups and permissions. AWS Cloud Formation, which has templates to deploy and manage your AWS environment. And AWS OopsWorks, which is the DevOps framework for applications and lifecycle management. So leveraging all of this together, we can now actually deploy complete end-to-end mission critical workload on the AWS. And it could be an enterprise, entire ERP system, or it could be a completely web-based OTT platform that you could like to use, or it could be even a game that you like to build actually. These all things you will be able to manage here. After that, how do you really get started on AWS? How using it? How you start using it? So there can be many ways you could do that. The first is the most important way to use what is we call AWS free tier. So this free tier, AWS free tier includes the AWS services available for all the new accounts and good for 1 year from the date of account created. So for 1 year, it is completely free. AWS free tier is completely free for 1 year. I will discuss this when we will reach towards it. Practically, we will see it. Okay, now what is there actually? AWS free tier allows us to use most of the AWS services, and it is available for all the new accounts, and it is valid for 1 year from the date of account created. I'll just quickly run through at a high level what's included. So you get about 750 hours of Linux or 750 hours of Windows machines. You get 5 GB of standard storage on Amazon S3, and you get about 750 hours of RDS, and like of an RDS instance you can get 50 GB of the data transfer out. These are the details of the spaces what we are getting in the free tier. Keep taking the screenshots for your references. Now it's important to remember that a free tier is not a free account. Users exceeds the free tier will be charged. Okay. And the free tier does expire after the first 12 months. But within this free tier, you have the ability to test and deploy and completely complete web applications on the AWS. So leveraging AWS EC2, Amazon S3, RDS, CloudFront, and deploy all the tests out of an engine, or you can say out of the entire application on the AWS. So now the first step that you should be looking at once you create a new account, it's important. The first thing that you do is to create user and create IAM user. IAM account, IAM user, that is identity and access management. And this is the way for you to be able to manage and create users and access, like restrict access to AWS resources within the AWS account. And simply now, with this IAM, you can control what resources are allocated or assigned to each individual users, and which user has access to which resource and what level of access as well. For example, you can say I may have a fork of multiple, people in my team or members. So my team who should not be able to add or delete server, but to just view, you could use to control create such roles using IAM. Here are the roles you will be able to create for your team. If you would like to have folks who can only access specific service such as EC2, you could create those roles as well, as now depending on how your organization is structured. You could now create user groups, and you can then start assessing roles to groups, as well as then you can start assigning users those groups also. The second one is the most important step, that is the enabling of the MFA, that is multi-factor authentication. So AWS is, like, simply it allows us to do multi-factor authentication for the AWS account, and users to the entire physical or software based tokens are created, and this product against stolen password. It is against stolen passwords and keyloggers. So we highly recommend that you enable the IAM users and also enable MFA, that is the multi-factor authentication, for the root account of all the IAM. In the root account of the IAM, you will be actually required to enable the IAM there, and then you will be having multiple factor authentication. Now, the next step is to launch the EC2. So, what is Amazon EC2? Amazon EC2 is our virtual machine that is like that are running in the cloud. You have compute control, and simply the you have complete control of the instances, and you can install any software that you choose. You can choose the other instance type and size to get a different amount of memory, CPU, disk, etc. And you will need a key pair in the security groups to launch each instance. Okay, so simply we talked about multiple instance type and Amazon EC2. There are multiple instances, and instance families are there. Instance families depending on the use case. So we have got a whole bunch of machines, like you can say, called M class machines, which are generally purpose. Which are general purpose. These are like a having good balance between the CPU and the RAM, and give a good communication for workload, which have an equal requirement for the CPU and the RAM. We have machines which are optimized for the CPU, which means that they have the high CPU to RAM ratio. Okay, so simply I was talking about M class machines, which are general purpose, and these are good, having good balance between the CPU and RAM. and they give a good combination of workload which have an equal requirement of the CPU and RAM. The machines which are optimized for CPU, which means they have the higher CPU than the RAM ratio, and these are ideally suited for workloads. Okay, so higher CPU to RAM, and these are ideally suited for the workloads which are consumed more than CPU, like where the more CPU than the RAM is getting consumed. So we have workload and have machines which are designed for more memory, and these are the R class machines. Simply, these are like R class is there. So R class machines are ideally designed for the workload which consumes more memory than the CPU or RAM. Sorry, for example, databases, and we have also got the entry level machines called the T2, which are all almost alike to the general purpose instance. The M family, but come a little differently in the sense that they allow you to burst out in the capacity and performance. And we also have other different types of families as well, which is input output optimization. So instances or virtual machines that are optimized for the input and the output operation machines they are, and that are optimized for the GPU, and or the machines you can say which are optimized for the storage. So really depending on the use case and this type of applications, you have the flexibility to choose the different types of instances, and which within each of these instance families there are different sizes, so you can choose 2 core 8 GB RAM, you can choose scale out of all the ways, or 72 core 256 GB ROM machines as well. Okay, so I hope you have taken the screenshot. Now there are multiple purchasing options, which is which comes to easy to, and the important, and it's simply important to understand the difference between the three. What is the difference among them? So on demand is the purchasing model that allows you to pay as you go. So you pay uh, like uh, you pay by the hour for the number of hours and that you run your machine, and there is a fixed price, and all of this is available on the AWS website, and you will be billed by the size of the machine for down machine sorry number of hours, and simply you run the minute you switch off or shut down your machine, you get your bills done. And bills does not get generated, so it's almost likely to running the electricity. You switch on the line and your bills get generated, and you switch off the light, you are not able to you are not billed for exchanges. So you have also the option to reserve these instances. So the example, that you are going to be running some of these server for say a year or 3 years. So you have the ability to say, I want to reserve these instances, and in return, AWS gives you the significant discounts also. And the discounts could be always between 30 to 70%, depending upon the depending on the terms of the instances and dependencies. On the term, you will need to commit you to and assign the volumes you are willing to commit to. Okay, we have to understand that when we are also doing the work there, so we have to be committed out of it. We should be committed, and properly on time we do the things. AWS also has the third model called Spot. And this is massive infrastructure and a lot of infrastructure many times in the, like, you can say, unutilized. And what AWS essentially do is to allow you to bid for this information at cost, which you which is almost 90 people, 90% cheaper. Talking about sim. Oh, sorry. Now I'm just repeating the thing of Spot, which I was saying. That workload on Spot instances, making it almost 90% effective. However, I would like to highlight that Spot is not a good use case for everyone, for every kind of work. Now, let's discuss about the AWS impact. According to O'Reilly, 90% of the organizations are expected to increase their cloud infrastructure. Okay. Then, in 2024, the upshot, actually in 2021, you can say, in 2021, the upshot is that the majority of the cloud users plan to scale their business and in the cloud, and rather reducing their cloud storage share. Then, like, the COVID-19 pandemic led organizations to increasingly shift to the cloud, which helped them to improve business community. With the help of that, they were improving the business community. Then the official meetings, like video conferencing, were done with the help of Zoom meetings, Google meetings, and all. So this all you must be knowing. These things are very easy. Okay. The famous cloud provider in the market is AWS, Microsoft Azure, and Google Cloud, all of which have been strong. AWS, or Amazon Web Service, has been known for its rapid pace of innovation in cloud computing. And this year is no different, actually. It is getting increased. AWS is the leader in public cloud provider and has more significant impact on modern technologies like machine learning, robotics, IoT, etc. Now, Amazon Web Service is an online service provider that offers various services such as compute, power, storage, database, content, delivery network, and other resources to help businesses to uh, scale and grow. And these services are provided basically on the subscriber basis. Talking about the journal features, Amazon Web Series was simply found, you can say, in the year 2006, and apparently it holds the market share of 38%, 38.7. Actually, 31 it's written, 31 is old. 38 point something it is right now. Okay. So when we talk about AWS, it provides us approximately 175 fully featured services, and it consists of significant benefits like compute, storage, data networking, analytics, robotics, machine learning, artificial intelligence, and all. Simply when we talk about the benefits, so five primary reasons, you can say, why AWS is essential and how it can influence your business. So simply Amazon Web Services has various benefits that user rely on them firstly, and it allows you to set up virtual office, which will reduce the cost of maintenance and like you can say, maintaining and monitoring your infrastructure. So secondly, compared to the open premises environment, AWS providers, it provides a high level of data protection and a lower cost of its user. The thirdly, it is based on thirdly, on the basis of the requirement you receive, you can scale up or scale down. Fourthly, in the case you face a power failure or any crisis, having your file storage in the cloud ensures it to be backed up and secured in the like safe locations. And lastly, in short, AWS offers high scalable services for database warehouses. Okay, and when you talk about data warehouses, transcoding, storage, backup infrastructure, management application, etc., which help in reducing the overall time and effort spent in like setting up and managing the infrastructure. Okay, so this was about the introductory portion which I've discussed with you right now. I'm just going to once again start with this top like Amazon free services, and I will be explaining all of them. Listen to me carefully, and revision material also I will share with you. And here you can see AWS free tier is there. You can just come here and you can just go for the creating of the free account. As I told you, I was just having the free tier account, but it was ended 2 days ago. And simply whenever you are having your free account, you have to make sure that account you are not using like you are using only when you are having your project. That is the best thing, because here it will be taking your payment options and everything, as I told you. In the other platforms like Amazon Premium, oh sorry, YouTube Premium or Netflix 1 month free trial and all who are present. So there they actually ask your payment details also, and then only they allow you for the free version. So here three types of free offers are present. That is the free trials, 12 months free, and always free. So like simply you can see three types of the offers are there. More than 100 AWS products are available on the AWS free tier today. So depending on the product usage, you can go for it. Suppose you just go here to click click for the free trials. So simply these are free offers, short term trials. And when you go for the 12 months, so this is like the validity of 12 months, and this is always free. So always free are very less actually. You can just see this, and it will be your assignment also that you should go through it by yourself also. That will be helping you better to understand these things. I'm going to give you a complete overview of it today. Here, as I was telling you previously, that the product and categories which are present, so compute, database, storage, container, web and mobile applications, serverless, and machine learning. So here, when we talk about the services, you can see if I just go for this trials. So whatever trials present are here, like suppose related to the analytics I want to see. So the names are there, and we have already discussed about them at the time when I was discussing the things from the PPT. At that time, I have told you these things. So quick site, cloud search, Redshift, I have talked about them previously. So suppose this Amazon site is simply free trial version, and simply 10 GB of space capacity for the first 30 days for total 4 users. So simply you can add 3 more users up after your ID. Then here in the cloud search, Amazon Cloud Search is a managed service in the AWS cloud that makes simple and cost effective setup. So simply here you can see that 750 hours it is giving, 750 hours of Amazon Cloud search instances and 10,000 document batch uploads. So this is the detail here, 10 index document. In the case of the Amazon Redshift, power driven data decision is there. So this is here. There are like, if you choose containers, so two are there, ECS and Amazon Light Sail. Then you can just choose your requirement. Like suppose database I am going with. So there are different multiple database options available to us. According to your requirement, you can go for it. If you are having a robotics related project, so you want databases in and also the robotics project related mechanisms. So here you can see RoboMaker and all is there. So these are of 1 month free trial, free trial. That is the thing which I told you, that everything is not free for lifetime. It's not free for 1 year. It's not even free for 1 year. You have to understand this thing, that free trial is different and 12-month free is different, and always free are very rare. If I go to the always free option and I just remove this, so all from the always free will be coming. Here you can see what is always free. DynamoDB is always free, but that is giving 25 GB storage. Now, how long you can use that? It's completely up to you. If you end it in 1 day, that's over. If you end it till lifetime, that's lifetime free. AWS Lambda, 1 million free requests per month. So 1 million free requests per month you can get. So it is good. This is good. So 1 million free requests per month, up to 4 million, 400,000 GB seconds, or 3.2 million seconds of compute time per month. Now, cloud, sorry, this is like unlimited for the cold storage, Code Whisperer, Amazon Code Whisperer Unlimited. Code suggests for individual tiers. So it will be also suggesting us the code, your AI powered productivity tool. So these are the lifetime free tools. Right now they are lifetime free, but in the future, if they are going to be paid, nobody knows. Right now, it is always free. Then, if you go for the 12 months free, so there are some other services. So, according to your requirement, you can choose them, as we have discussed about these things in the detailed when I was talking. I have not explored all of them. There are millions of things available, actually, millions of things. Millions, because there are so many sectors, they are having 4,000 plus services, and inside that, you can explore it, and the combinations will be millions. Like combinations will be million if you just combine them according to a requirement, so that you have to go through it. Just give your half an hour daily to this. I just give you half an hour daily to this, and you are going to get a lot into it. So here, if you go to the pricing, so in the starting, it will be like showing you the free tier only, because first you have to create the free account and then you go with it. It's asking me for my account, but I am not having any account right now. Like complete sign up, it is showing, because I have not completed the sign up. I won't be even able to do that, because simply this ID is already registered with it, and it's not about the ID. It's about the IP address. You can't use the same IP address again and again. Okay, that is the thing. Either you change your device, change your ID, change your account, then you can use it multiple times for the free tier account. But yes, that's the point that you have to understand. That's why I'm saying get started only when you are ready with your project. You have something, then start. Just and for only for the exploring the services, you can definitely go here only. All the things are open, but you will be able to use them, select them only when you are ready with your project. So these are the things. There are a lot of documentation also available related to this. We have also discussed about it, and you can definitely explore this part also. They are giving the good documentation to make you understand about this. You can go for the PDF version or the Amazon, HTML version. So they will be giving you notes out of it. You can just read them. You can understand their documentation things are there, because whatever latest upgradations are there, that is mentioned here. So these are the like good, 3018 pages. You can't complete every one of it, but yes, you can definitely go through it. You can just see your requirements, and accordingly you can just go through the documentation also, because these things are very very in depth, if you really go for it. Okay, now simply if you go for the storage, and the storage, I'm going for the trials. So this is here, free trial, Amazon ECS Anywhere 2200 hours. 2,200 are per month you get, and it is more than sufficient. And it is having 6 months free trial. If you just go for the 12 months free, so there are three options available in the storage. So this way you can just choose that what option you require. Like this is storage option, and here in the storage you are going for the 12 months free. So you are going to get 1 year free definitely in any condition, because there are different options which you can use, and with the help of that you will be able to work with it. Okay, how many of you have started with the assignments, like really working but not submitted? How many of you are working but not submitted? That you are working but you are not submitted. Okay, no one else. So I was talking about the storage, AWS storage gateways. Now, as today we are discussing about the AWS, we will be also exploring the Google Cloud Platform and Amazon Azure. So simply, we will be also going for the compare and contrast things. Okay, so as I told you that we will be discussing about different stuff, different related cloud platforms. So AWS complete demonstration and all I have gave you previously. AWS demonstration I gave you completely practically also. And today I will be starting with the Google Cloud Platform overview and demonstration I will be giving you. For it, there are multiple cloud platforms. We have already talked about it in the initial sessions. And today I will be starting with the Google Cloud Platform. So when we talk about the Google Cloud Platform, it's a suite of public cloud computing services offered by Google. So the platform includes a range of hosted services for compute, storage, application development that run on Google hardware. So Google is having their own, hardware, their servers where all the things are getting stored, and the computation and performing, like all the tasks is getting performed. And simply, when we talk about the Google Cloud Platform, that is GCP, is a suite of cloud computing services provided by Google. And it is a public cloud computing platform consisting of a variety of services like compute, storage, networking, application development, big data, and many more, which run on the same cloud infrastructure that Google uses internally for its end user products. So simply what products end user is using, like what we are using, the Google Drive, the Gmail, the simply the you can say Microsoft kind of suite. The Google is also providing the Google Sheets, the Google document and all. So that is also like that is the end product. So what platform, what services, compute, storage, networking, and all it is using for itself to provide the feasibility to the end user, the same is getting provided to us also for uploading our products. So this like the service of the Google Cloud Platform can be accessed by the software developers, cloud administrators, and IT professionals over the internet through or like you can say dedicated network server. So the dedicated network connection is there through which it is possible. If we talk about that is Google Cloud better than AWS, so simply it depends on the requirements. Although AWS is simply dominating the market. It's always dominating the market. So Google Cloud Platform is free tier. Okay, Google Cloud Platform is free tier, and it is also more robust than AWS, including 28 front-end instance hours. It is also giving 28 front-end instance hours and 9 back-end instance hours per day on the Google App Engine, and 5 GB of the regional storage on the Google Cloud Storage, and 1 GB of the storage on Cloud Firestone, GCP, and NoSQL document simply database it is providing. Then if I talk about the free account, so simply all Google Cloud customers can use to select the Google Cloud products like Compute Engine, Storage, BigQuery, free of charge. It is simply free with a specified monthly usage limits. It is giving free account, but the limitation is when you are using their services. So that is the point. And simply, I'm just going to show it to you that how you will be able to work with it. So simply the GCP you can go for, or simply you can go for the Google Cloud Platform. This is here, and you can just use this. Here you can see I'm just sharing this link also, or just a second. From here also you can go, or anywhere. So I'm just sharing this link also, although you can just directly search the Google Cloud Platform and then you are going to get it. So here, that is the GCP, and this is the direct link for it. Although I don't know why it's okay, this much it is. So if you just use this link, so you will be reaching here only. Okay. So this is my Google Cloud Platform, like free account. You can just get started from here. You can just get in with logging in, signing up with your Gmail. Okay, you will be doing that for it. So simply, it comes at why to use the Google Cloud Platform. Okay, so most companies use the data centers because of the availability of the cost forecasting, hardware certainly, and simply you can say the advanced controls. However, they lack the necessary features to run and maintain resources in the data center. And GCP on the other side is fully featured cloud platform that includes the you can say like features like a capacity, that is a sufficient resource for easy scaling whenever required, also efficient management of those resources for optimal performance, the security, that is multi-level security options to protect resources such as assets, network, and operating system components. Then the network infrastructure, if we talk about, so the number of physical and logistical and human resources related components such as like wiring, router, switches, firewall, these all the network infrastructure related components, load balancers, etc. That is also best you can say. Then the support, so skilled professionals for the installation, maintenance, and support team. The customer support team is there. Team is there. If we talk about the bandwidth, suitable amount of bandwidth for peak load is provided. So, like the facilities, you can say other infrastructure components, including physical equipment and power resources, is there. So GCP is also providing us a lot amount of features and services, and that is free also. But yeah, nothing is actually free. It's not 100% free. You can create a free account, but resources are mixed. Some like they are having limited durations. That's the point. If we talk about the benefits, so benefits of the Google Cloud Platform are like simply the best pricing. So Google enable users to get cloud hosting at the cheapest rates. And the hosting plans are not only cheaper than other hosting platforms, but also offer features than other, like good features as compared to the other service provider. And simply the GCP provides as pay as you go option. So that is simply pay as you go option, which is present in the AWS also. It is provided here also to the users, where the users can pay separately only for the services and resources they want to use. Only for the services they want to use. And the work from anywhere facility. So once the account is configured, on the Google Cloud platform. It can be accessed from anywhere. Your mobile you can use to access it, your laptop, your tablet, wherever you are sitting throughout the world. Using your Gmail ID, you are logging in the Google Cloud platform account and you can just use it. It is possible because Google provides web-based applications that allow users to have complete access to the GCP. Then the private network options. So Google has its own network that enables users to have more control over the GCP functions. Due to this, users achieve smooth performance and increased efficiency over the network. So these are the benefits and the scalability obviously. And users are getting a more scalable platform over other private networks because Google used the fiber optical cable to extend its network ranges, and it's likely to have more scalability. Like Google is always working to scale its network because they can be any amount of traffic at any time. They are never like every time they have to take care of this thing. The monitoring is there. that what amount of traffic is coming to the Google Cloud platform or the Google is facing. That is the thing. That is the point. I hope you are taking the screenshots for your references. Please tell me whatever I'm discussing, is it getting clear? Yes or no? Okay. So let's move further. Then simply the like this is the benefits once again, security and redundant backup is also benefits of it. When we talk about the security feature, so there is a high number of security professionals working at Google. It's obvious that they always keep trying to secure the network and protect the data stored on the server. And additionally, Google use the algorithms that encrypt all the data on the cloud platforms, and this give like assurance to the users that the data is completely safe and secure from the unauthorized sources. So the security is very high. The like redundant backup when we talk about, and simply Kishan, you can do it anytime because the Google Cloud platform is not providing us that limitation, that free tier account kind of. You can directly set up this one. I just told it. You were not present in the class that time. Okay, I started with it. It is giving us like $300 free try, like free credit, sorry. And simply you don't have to worry about the, the account expiration. You just have to add the payment methods and you have to get into it. Okay, you have to add the payment method just like the Netflix you do, same way. So when you will be doing it, so what will be happening? Like because the services, all the services are not free. They have given the free account option. So free account option is there. The services are not free and they are having limitations of the duration. That what for what duration it is free. That is another point. So simply after that it will be chargeable. And once you get into it, you will be easily getting those details. I'll show them to you definitely. Okay, but yes, you are free to use it anytime. For the Amazon, like you can say AWS, when we were going with the like, demonstrations and all, I told you everything, but I told you that okay, when you are ready with your project, then only create the account because there the months will be wasted. If you create your account and you are not using it instantly, you are wasting the months. After 1 year, it will be not free in the case of the Amazon Web Services. But in the Google Cloud platform, you can create your account anytime because it is completely free. The account creation process it is there, it is going to be free for you, but yes, you have to make sure of you have to give the payment options in the starting only because all the services are not that free, that much free. It's a redundant backup I was discussing. So like Google always keep backup of the users data also within the built-in restaurant backup integration and all. And in the case of users has lost the storage to simply store data. So it is not a big problem because Google always have the copy of the user's data. Obviously, it is simply redundant. That means repeated backup. And I will suggest you all to please start working on your assignments and project work because you already have got 3 project topics. And for all the alternative off sessions, I already have given you a practical stuff to work with. And if you are not doing it, so I'm not responsible for it. You are going to be responsible for your performance. Okay, today I am going to start with some concepts related to database management system. And for the reference, actually it is not going to be the reference stuff which I will be giving. I will be giving you some additional learning assignments which is related to database management system. Why we are studying the database management system? Because database management system is simply an integral part of cloud computing. When the cloud also somewhere the data is getting stored now, we don't have to maintain our own databases. We do not have to maintain our own databases as the hard drives or something. We have to store the data on the cloud in the cloud computing. But still, when the cloud is getting that data, so somewhere that cloud is storing the data, na? Cloud is having their own server, database servers, where they are able to maintain the data of the end users. We are the end users. So cloud maintain the data in their databases and how they are maintaining them. That is the point. What phenomena they are using. Like there are different servers, the replication of the data is taken care and many other things. So those all things are taken care. And how it is getting done, that I have discussed in one playlist. That complete playlist I will share with you. But other stuff what is not shared in the playlist, that I am going to discuss here. Additional learning I will share with you in the classroom. Is it okay with everybody? Please answer. Please be attentive and answer me. I want consistent answers from your end. Is it okay? Yeah, please answer. Okay, thank you. Now you all just start learning, going through the internship stuff once again. I know you were having exams, but still now you have to resume with this internship, and there will be no extra gaps or something. And on the alternative basis, as the classes were going, it will be going. We waited for you all a lot because of your examination. It was also necessary, but now please let's resume because things are lined up. Now when we talk about this advanced database management system, like what is database management system and the basic stuff I have discussed in that particular playlist, which I will share with you. But advanced database management system have some advanced concepts, although DBMS is simply the database management system, and the multimedia database means when you are storing the data related to the multiple media. That means multimedia means images, videos, all the different formats of data. When it is getting stored, it is known as multimedia database management. And simply, it is a collection of interrelated multimedia data that includes text, graphics, sketches, drawings, images, animation, video, audio, etc., and have a vast amount of multi-source multimedia data. So simply in the cloud computing, why I am including this concept, because anyhow we are having a lot amount of data which we are storing on our clouds, and how cloud is maintaining and what cloud is actually doing at the back end, that I am trying to discuss. So the frameworks that manage different type of multimedia data which can be stored, delivered, and utilized in different ways is known as multimedia database management. How this data is managed, processed, and stored, that particular phenomena is known as multimedia database management system. And there are three classes of the multimedia database, which includes the static media, dynamic media, and dimensional. So these are the three different classes, or you can say three different ways how the multimedia database management system works. Please keep taking the screenshots for your references. Now, when we talk about the applications of multimedia database management, I'm again showing this slide. If you have not taken the screenshot, please do that and keep it as a practice. So simply the applications, when we talk about the applications of multimedia database management. So first of all, like document and record management. First of all, the documents and record management, like in the industries and businesses, they keep their details record in variety of documents, insurance claim record and many other, in bank and all. Now, like they are not having their offline, that is on their application, and their application is having the cloud, obviously. So there are different documents. So document and record management in banks and insurance companies and businesses and organizations. Okay, then knowledge dimensions. So multimedia database is a very effective tool for knowledge sorry, for knowledge dissemination in terms of providing several resources, for example electronic books. So for the learning purposes, there is a lot amount of data which we consume from the internet as users. We search for data, we have ebooks, we have videos, we have like multimedia, and that particular thing is known as knowledge dissemination. Then the education and training. So computer aided learning, computer aided designing. So computer aided learning materials can be designed using the multimedia sources, which are nowadays very popular source of learning, like digital libraries, YouTube videos, and not only YouTube, we are having so many different platforms. We are having a lot amount of ways to learn, from where we can learn, and they are having the resources in the PDFs, in the video formats. So that is education and training stuff. Marketing, advertising, retailing, entertainment and travel. So Netflix and all entertainment related, travel related data is there, advertisement is there. So virtual tour of cities and all, blogs, travel logs, so many things related to that. Real time control and monitoring. So coupled with like database technology, multimedia presence of information can be effective means of monitoring and controlling complex tasks like manufacturing operations. So these kind of operations are also maintained anyhow, like manufacturing is getting done. So from the very initial phase, from the very initial step, the process is taken place, and that is also stored in the video format, in the multimedia format. Then there is one database which is known as spatial database. Now, actually, as I have not given you that particular source, which I am going to give you today, related to the database management system, as I talked about a complete module playlist. So that playlist I will share with you. I wanted to share it before only, but your sessions were not going on. So that was a kind of a homework which you have to do before this class. But no issues. I will explain those things here. Otherwise, I was simply asking questions to you related to that. But you are now not having those questions from my end because I have not given you that playlist before. So simply spatial database I have discussed there also. And please make sure that whatever recorded stuff I am giving you, you have to go through it in any condition. If you are not going through it, I will get to know it. You don't have to submit anything in that particular database management system assignment, but you have to go through it. You have to do it because that is necessary related to your projects and all. It is having stuff. So spatial database is simply related to space. Okay, it's related to space, the geographies, the locations, the geo, that is the geographic, not GIO, that is GEO, geo, geographic. Okay, so like the map and all which we are having. So spatial database is optimized to store and query representing objects. We are having the Google map and all that map is stored somewhere in the cloud only. And that is the reason why we are able to get those locations in the very easier manner, because it is the real time use which we are making of the cloud, and we can just store that offline also. That's another point, but how it is actually getting done, that is spatial database. That is another way of working with the database. And the characteristics of spatial database management system is simply like spatial database system has simply it's a database system. It offers a spatial, that is SDTs, and data models and query languages. It supports spatial data types, and it's like in its implementations, providing at least spatial indexing. So how those cities, those small locations are stored in the indexed format. What algorithms are getting used there that are known as the like spatial join and all. So a roadmap is one example. As I already told you, a roadmap is a visualization of geographic information. A roadmap is a two-dimensional object which contain points, lines, polygons, and data representing actually the cities, roads, and political boundaries, such as states or provinces. So in general, spatial data can be of two types, vector data and raster data. So when we talk about the vector data, it is the data represented as discrete points, lines, and polygons. And raster data is simply like represented as the matrix of square cells. So this is the way that how it is getting represented, how it is getting used. Here you can see, take a look at it. You can take the snapshot of it, screenshot of it. So when we talk about the spatial data, so line, point, polygons are represented to us, and those things are actually stored in different variety of databases like Oracle, SQL Server, Sybase, DB2, many are there. Then next one is advanced database management, that is the mobile databases. So mobile databases are separate from the main database and can easily be transported to variety of places. Simply, that can be easily transported to variety of places. Even though they are not connected to the main database, they are still communicate, like they communicate with the database to share and exchange data. That means uh, when you are searching some website on the browser, or some when you are using it on your mobile app, their databases are different. They are not using the same database. The database for the mobile phones accessibility is actually stored in a different manner, different place, because it is having different frequency, different bandwidth is required. So that database is separately maintained. Okay, that is known as mobile database. And simply the mobile database include the components like main data, like main system database that stores all the data and is linked to the mobile database. Okay, main database is having everything, and then it is linked to the mobile database. So the frequently accessed things are actually maintained there in the mobile database. The mobile database that allows users to view information even while on moving. You know, when we are searching something on the laptop, desktop, we are usually static. But in the mobile, like the things are different. The IP address and the like locations and all change very frequent. So it shares information with the main database. And the devices that uses the mobile databases to access data, like this device is mobile phone, laptop, etc. What mobile means movement. It's not your phone. It's not the cell phone, mobile phone which we are using. Mobile means which is having movement. Okay. So simply the communication link that allows the transfer of data between the mobile databases and the main database. There is the communication link through which actually the transfer is actually possible. Then the advantages of mobile databases, if we talk about. So some advantages of mobile databases are that the data is in the database can be accessed from anywhere using a mobile database. Okay, anywhere we can be in any particular place and that will be accessed very easily. It provides wireless database accessibility. The database system are synchronized using mobile databases and multiple users can access the data with seamless delivery process. Then mobile database require very little support and maintenance. So you can understand this thing that the synchronization of the mobile databases is in such a way that the multiple users can access the data with the seamless delivery process. Okay, we do not have to worry about that. Okay, now it is rotating and it will give us the output. No, actually it is very instant and very little maintenance is required in that. That's why I told you that the mobile databases are maintained separately. Mobile means the movement. Don't compare and relate the mobile with the mobile phone. When we talk about mobile, so laptop also considered, laptop tablet is also considered there. Mobile means which is having movement. So the mobile databases can be synchronized with multiple devices such as mobile, computer devices, laptops, etc. as I told you. Now, when we talk about the disadvantages of mobile databases, so like the mobile data is less secure than data that is stored in a conventional stationary database. And this presents a saturatory hazards. Okay, like in the case of the hazards and all, that becomes difficult because simply it is less secure because it is very volatile in nature. So the mobile unit that houses a mobile database may frequently lose power because of limited battery, and this should not be led to loss of the data in the database. So this is simply a point you can say to be considered here, but still as the mobile database is having the direct connection to the main database, so the recovery is possible. Obviously recovery is there, recovery process goes, recovery of the data if their hazards are coming. So but still this is a disadvantage of mobile databases. Okay, everybody tell me till here whatever I have discussed, is it getting into your mind? Are you all understanding what I am saying? Are you all listening to me? Only two people? Everybody answer. Please be active here now. I need your responses. Okay. So further when we move, so simply the next thing is cloud database. Now cloud database we have talked before also, but still I'm discussing here. So nowadays data has been specifically getting stored over clouds, also known as virtual environment, either as a hybrid, public or private that we have discussed. So cloud database is the database that has been optimized or built for such a virtualized environment. Cloud databases are basically made for the virtualized environment. And there are various benefits of cloud database, some of which are like ability to pay for storage capacity, as we talked about pay as you go system is there, we talked about it earlier, and bandwidth or like on a per user basis. And they provide scalability on demand along with high availability. So a cloud database also give enterprises the opportunity to support business applications in the software as a service, that is SaaS development. We talked about it, software as a service like Gmail and all, our Google Sheets and all are simply software as a service. Here you can see, so master data and the replica data is there. So master data simply multiple copies, multiple replicas are made of one data and it is stored on the different locations. Clusters are stored and then the data is distributed because it can't be kept in one location obviously. Multiple master data are there according to the locations, and according to their master data location, their replicas are also multiple. For each data, different multiple replicas are created. Now, when we talk about the cloud computing technology, so simply there are certain technologies working behind the cloud computing platform, making cloud computing flexible, reliable, and usable. And these technologies are virtualizations, SOA, that is service oriented architecture, grid computing, utility computing. So these are like four different, you can say, technologies which are working behind the cloud computing technology to make it reliable, flexible, and usable. Virtualization, service oriented architecture, grid computing, and utility computing. So the first one which comes there, that is virtualization, and it is basically a technology which allows to share single physical instance of one application or resource among multiple organizations or tenants. Tenants are simply known as the customers, or customers are known as the tenants, or you can simply say is multiple locations they are. So virtualization is simply sharing the physical instance on multiple instances, and it does it by assigning a logical name to the physical resource and providing a pointer. Simply multiple replicas, multiple resource, you can say, are created with one single physical instance, one single instance. Then simply the multi-tenant architecture offer virtual isolation also among the multiple tenants, so they don't know about each other actually, and hence the organizations can use and customize their applications as though they each have their instances running. So here you can see this is simply the architecture model image. You can see diagrammatic representation. Okay, so this is the network and storage, then virtual interfaces. This is virtual machine 1, 2, 3, and n number of virtual machines are connected. And this is the virtualized cloud model where user is here, application, operating system. You can see here one user is there, second, third, fourth, this way it will go. Now the next one is the SOA, that is the okay Meghna. I am just showing the previous slides. This one, I think. This is the slide and this is the diagrammatic representation. Now the next is SOA. SOA is simply the service oriented architecture. So service oriented architecture helps to use applications as a service. Application as a service for other applications, regardless of the type of vendor, product, or technology. So service is simply like we have, suppose you have created one software, and that software is one application, that is a product, digital product, and that application you have simply given to me. I am a company, suppose you have created a project, you have given it to me that okay, sell it. I have simply given you the amount for that software, and now it is getting sold. So one particular software is created and multiple different users are purchasing it from me. Now simply that is a kind of a service which they are using. So it is simply what? An application as a service. Therefore, it is possible to exchange the data between applications because it is an application, so data exchange will be there of different vendors without additional programming. Okay, there is no requirement to change anything. Only the software is required. You need a calculator, I need a calculator, so many people need calculator. One calculator is created and that is an application which is getting used as a service. And there is no changes actually required to be made. It's not always required to change anything. We use calculator and it is always same, and still we use every time in our mobile phone or somewhere on our desk. So similarly, I'm just trying to give you an example of it. Microsoft Word you consider. But yeah, there are like updates. Updates are simply according to the business requirements actually. That's another point. So here you can see this is one diagrammatic representation. So here you can see desktop or authoring tier, server publishing tier, integration platform, and this is subscription tier. Mobile application, 2D, 3D, 4, like simply GIS application. GIS and all I have discussed in that playlist. I will share it with you. I am telling you, it will be with you. You will go through it, and please complete that before the next class. That assignment which I will be giving you, that you are required to complete before the next class. Then only it will be fruitful. Otherwise, if it will be of no use. Okay. Now the next thing comes, that is grid computing. This is the third like component there, technology. So grid computing refers to the distribution of the computing services in which a group of computer from multiple locations are connected with each other to achieve a common objective. So simply, we all are connected to each other to accomplish one object. What is the objective? You are learning, and I am simply giving you the knowledge, and our objective is to do something different by this learning process. Okay. Simply, my objective is also that you do something good through this knowledge, and your objective is also to do something good, to make some good output, so make some good project out of this knowledge. Both are having the same objective, and we all are connected to each other. N number of students are connected to me, for example, and they n number of students are on different locations, and we all are connected to each other with one particular point, which is this program, you can say, in which you are present right now. And simply, it is a kind of a grid, because we are having a common objective, and we are are heterogeneous and geographically dispersed. Okay, resources are heterogeneous. Someone is having i7, someone is having Razor, someone is having i3, i5, Windows 10, Windows 11, someone is having MacBook. Okay, so different heterogeneous resources are there, but we are geographically distributed, but we are connected through one grid. Grid computing breaks complex tasks into smaller pieces. Now, I was going to all of you individually and giving you the learnings. So that is simply complex task. But with this, we are actually making it possible in simpler way. One time, one go, and many people are able to learn it on the same time. I'm just giving an example to make you understand. So simply, now here in the computing manner, you can talk about the processors, that multiple processors, everybody is having their own processor. So we don't have to worry about that, okay, someone is coming in the physical location, and in the physical location, the company has to maintain so many amount of computer systems. Now this is biode. You are bringing your own device. You are using your own device. You are having your own processor. You are having your own CPU. So whatever is the requirement of your project, that you are fulfilling by yourself. So the load is distributed among n number of computers. The load is distributed among n number of computers. Here you can see, take a look at it. This much clear, please tell me. Whatever I have talked about till now, that much clear or not? Grid computing and all. Is it interesting? Everybody answer. So simply, this was our today's work, which we had to do. Like simply, I have talked about this virtualization, service-oriented architecture, grid computing. Utility computing I have already discussed. If you remember, when I was discussing the AWS at that time in very detail, of complete session I have taken on the utility computing. So that's why I have not included it in today's session. So that's it. Now I will be sharing with you the resources also. Today's topic is TCP, IP, and OSI reference models. And these are the two network models, you must have heard about them. So simply, first of all, let's see that what I am going to discuss today. First of all, we will be talking about the introduction. Then we shall cover the OSI reference model. Then I will talk about the TCP/IP reference model. They both are the two different models. So we shall compare and contrast them. Then first thing which I am going to talk about, that is introduction to the TCP/IP versus OSI reference model. So a comparative study I would like to do here. When we talk about it, what is the purpose? So simply the primary goal of this comparison is to understand the similarities and differences between the TCP, that is the transmission control protocol, TCP/IP, that is the transmission control protocol and internet protocol, and OSI, that is simply the open system interconnection. Okay, reference model. So these models serve as a blueprint for how the data is transmitted and received over the network. Either you are learning cloud computing, then also the network transmission and all is very necessary to be understood. Or you are doing the IoT, then also it is very necessary. So this is a really very important topic. So that how the data actually travels on the network. So that is actually discussed when we talk about the models, the OSI and the TCP. So let's talk about the overview of the networking and reference models. When we talk about networking, it is the process of connecting the devices together for the purpose of sharing information, obviously, to ensure the compatibility and interoperability between the different devices. So network means that interconnection of different networks. We will be able to, different devices, you can say, and we will be able to share the data among them. So these models provide the conceptual framework. What are these models? These models actually provide us the conceptual framework for understanding the various layers involved in the network communication. Now, simply as I said that like it is the model which provides us the framework. That means it is a conceptual model, and it gives us a blueprint that okay how the network is actually working. When we share some data on the internet, when we work on the internet, so how the data is getting transmitted. There are multiple layers through which the data gets transferred, and all those layers are actually having their own dedicated purposes, dedicated work, you can say. So simply the reference model serves the following key points. OSI reference model, okay? The reference model is simply the open system interconnection model. And there are the different functionalities. The first one is the standardizations. So simply they provide a common language and framework for the network designers, developers, and administrators. So all the people who are connected to the network, who are actually working on the network, they will be able to understand that okay, what is the language, according to that only everybody will be working. There is a common standard language to communicate, and this is actually the common language. When we talk about the problem solving, so by breaking down the complex process of network communication into smaller and more manageable layers, they help in identifying and resolving the issues. So simply whenever there is a network connectivity, whenever the data is getting transmitted or transferred over the internet, there is always some, you can say, uh, problems or issues generated. So to manage those issues, the problem is actually broken in multiple parts, you can say. So smaller parts, and those smaller parts are actually helpful to understand and manage the problem. So different layers are there, and that is actually giving the problem solving approach by breaking down the complex process of network communications into smaller and manageable layers. The education, so simply they serve as a valuable tool for teaching also, and understanding the networking concept, as I am doing right now, that I am trying to make you understand that how the network works, and that will be helpful with the help of the OSI reference model. Now let's talk about in detail the like OSI. So this is the diagrammatic representation, and here you can see that sender and the built up packets and receiver is present. So the OSI model is a 7-layer model that provide a detailed view of network communication, and each layer performs specific functions and data flows from the application layer at the top to the physical layer at the bottom. So from application layer to the physical layer, what are the different 7 layers? Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. If you number them, so the first number will be actually the physical layer. Physical layer is kept on the number 1. So 1, 2, 3, 4, 5, 6, 7. First is physical layer, second is data link layer, third is network layer, fourth is transport layer, fifth is session layer, sixth is presentation layer, and seventh is application layer. So application layer is on the top. Application layer is actually the on the user end, from where actually the data is getting transmitted. So either on the sender or on the receiver, on both the ends, these 7 layers are working in every condition. Wherever you are, whatever data, a mail is getting transmitted, a message is getting transmitted, a voice note, a file, whatever. Whenever you are making the connectivity of internet, that time this is working. Now the first layer, as I told, the like we will talk about from the top to bottom. So simply the application layer, the topmost layer that interacts directly with the user. As I told you, it is simply for the user interactions, and this provide services like file transfer, email, and remote login. Then the next is the presentation layer. So it handles the data formats and encryption, decryption. So whenever the data is getting transmitted over the internet, that time obviously the encryption and decryption of the data is going on. The encryption and decryption of the data will be going on at that time. So this is present. Presentation layer is the if the working of presentation layer is to format the data, encrypt the data. Then the session layer establishes and manages the data transmission sessions actually, and simply it establishes and terminates the session between the communicating devices. So obviously the communication will be between multiple devices, one to one, one to many. So simply there the session starting and termination is actually managed and controlled by the session layer. Then the transport layer, as I told previously also, that UDP is there. So simply user datagram packet. So like it ensures the reliability and in the delivery of data, and it includes the protocols like the TCP and UDP. So TCP is a protocol which is present in the OSI model. TCP is the transmission control protocol, and UDP is the user datagram protocol. These are present on the transport layer. That is the fourth layer. Then the network layer. So the network layer simply handles the routing and addressing of the data packets when the data is moving on the network. So their route and their addresses will be divided and decided by the network layer. And it uses the protocols like IP. So here in the transport layer, the UDP and TCP are the protocols. In the network layer, IP, that is the internet protocol, is present in the network layer. Then the data link layer is there. So as the name implies, it deals with the physical transmission of the data frames. So it includes the protocols like Ethernet. So Ethernet is actually one protocol which is included in the data link layer, which is used in the data link layer. Then we have the next one, that is the physical layer, the seventh one. So it defines the electrical, mechanical, and procedural specifications for transmitting bits over the physical medium. So for the transmission of the bits, that means bit by bit, the data will be transmitted over the internet. So when it is said that it is getting transmitted over the internet, so definitely through the physical layer, data link, network, transport, session, presentation, application. This way it is actually going. Okay, the topmost layer is the application layer. It's quite clear that the topmost layer is the application layer, which is present on the user end. So these are the 7 layers. Now the next thing is the TCP/IP reference model. So OSI reference model I have already discussed. Now I am talking about the TCP/IP. So this is the diagrammatic representation. You can see in the TCP/IP reference model there are only 4 layers. The TCP/IP reference model is like modern, you can say modernized, or you can say refined model, which is having only 4 layers: application layer, transport layer, internet layer, and network access. So network access layer 1, layer 2 is internet layer from bottom to top. Okay, and then transport layer and the application layer is there. So TCP/IP model is the 4-layer model that is more closely aligned with the actual implementations of the network, because it is a refined model. See, these are the conceptual model. These are used for the understandability that okay, on which layer what is working or what is actually happening. So it is often considered to be simplified version of the OSI model. Then let's talk about the 4 different layers in detail. So the first one is the application layer. Similar to the OSI application layer, this also have the same functionalities. For the user interaction, it is there. Then transport layer handles the reliable data delivery using the protocols like TCP/IP and TCP and the UDP. So transport layer was having the TCP and the UDP protocols in the case of the OSI reference model also, and these two protocols are there in the transport layer in the case of the TCP/IP model also. Same. Then the internet layer is having the IP. So there we were having the network layer, there the IP was present. But in the case of the TCP/IP model, the internet layer that handles the routing and addressing of the data packets using the IP, that is the internet protocol, which protocol is present here. Then the network interface layer. So it deals with the physical transmission of the data frames, because data is transmitted from one place to another in some frames. bits are there and bit by bit the data is transmitted. Okay, so let's talk about the comparison of two models. Now, simply the comparative study is quite simple. When we talk about the features, so the number of layers in the OSI model is 7, and simply in the TCP/IP it's 4. The focus in the case of the OSI model is theoretical and conceptual, but the TCP/IP is the refined model, so it is having the practical implementations. So it is a practical and implementation oriented model. Then, in the case of the like standardization, so OSI is having the higher standardization and in the TCP lower, because obviously it is having so many different layers for all the concepts. That's why it is having higher standards. Then the relationship to real world implementation. In the OSI, it is less direct because it is a theoretical model, but in the case of the TCP/IP, it is more direct because it is a practical model. So OSI TCP/IP reference model comparative study. I'm just comparative analysis actually, or study. It is the same thing. So the comparative analysis actually consists of the similarities and differences both. The comparative analysis is simply comparing two things. When we are comparing, so it can be similarities also and it can be differences also. So I am talking about the similarities right now. So simply both both the open system interconnection, that is the OSI, and the TCP/IP, that is the transmission control protocol, and the internet protocol model were designed to provide a framework for understanding and implementing the computer networks. So that was simply the common objective of both, either the OSI or the TCP/IP. Then simply the first you can say is addressing similar networking functionalities. Like both model address the fundamental functions required for elective network communication. Okay, so both models address the fundamental functions required for effective network communication. So simply both are built for the understanding of the network, that they actually deliver the effective network communication. Then the second functionality is data transmission. So it ensures the data is sent from one device to another. And data delivery, so guaranteeing that the data reaches to its intended destination, that is also necessary. Then error control, so detecting and correcting errors that may occur during the transmission. So error control, so these all functionalities are actually taken care in both of them, either the OSI or the TCP/IP, because they all these all are the similarities. The flow control, managing the rate of data transmission to prevent congestion. So these are the similarities. Now let's compare and contrast these models in very detail. So, so common layers are like application layer, transport layer, network layer, and data link layer. So these are anyhow common. Name can change, but their functionalities are common. But yes, application, transport, network, and data link layer is similar. So in the one model it is data link and another model is physical transmission, physical layer. So that is the name interchange. But yes, the functionalities are same. Application layer is on the top. It is a top layer that interacts directly with the user application. Transport layer is responsible for end-to-end communication between the processes. Network layer handles routing the data packets across networks. And data link layer is concerned with physical transmission of data frames over the physical link. The differences, if we talk about, so the number one is number of layers. OSI has 7 layers, whereas the TCP/IP has 4 layers. So the second difference is functions of corresponding layers. What functionalities are different? So session layer in the OSI model it is present. So it handles the session establishment, management, and like termination, which is often integrated into the transport layer in the TCP/IP. Then the presentation layer in the OSI. So it deals with the data formats and encoding, which is typically handled at the application layer in the TCP/IP. Then the standardization, if you talk about, so the OSI model actually is a standardized model developed by the International Organization for Standardization, that is ISO. So it is also known as the ISO OSI reference model or OSI ISO reference model, which is providing a formal framework for network protocols. And TCP/IP is a de facto standard with widely adopted, you can say adopted and implemented without formal standardizations. So simply these are the differences. If you go for the visual comparison, so the exact mapping between the OSI and the TCP/IP layers can vary depending on the specific implementations, because obviously there are 7 layers, there are 4 layers, so that is the difference. Major difference, because there are so many layers which are present in OSI which are not present in the TCP/IP. However, the general relationship between the two model is illustrated in the diagram. And diagram I have already shown you, and I will show you once again. Simply, in conclusion, OSI and TCP model serve similar purposes and different purposes. Both the things are there, but ultimately these are standardizations. These are the rules which are used for the network configuration, implementation, and configuration. Okay, design, implement, and troubleshoot. Here it is. Okay, so this is the OSI model, obviously. So this is the diagram for the TCP/IP reference model. This is very common diagram which you can find anywhere. Now, if I talk about the OSI model, so simply the open system interconnection, that is the OSI reference model, is a conceptual framework that defines the layers of communication in the computer network, and it provides a standardized way to understand and design network protocols and systems. Here you can see, first one is the physical layer, and simply the functions of the physical layer. I tried my best to keep the images here for you to understand it in a deeper manner, because these are the conceptual part. So simply the function is bit transmission, and it sends individual bits over a physical medium, copper wire, fiber optical cable, wireless, that is the Bluetooth and all, any. But yes, it is simply for the bit transmission. Signal encoding, the physical layer I am telling, the functionalities of the physical layer. So it converts the digital data into the electrical signals that can be transmitted. Then the media access control, so it regulates the access to the physical medium. And the fourth is the repeaters and hubs are the devices which are basically used when you are talking about the physical layer. So when we talk about the physical layer, so the repeaters and the hubs are the devices which gets used. Then the next one is the data link layer. So in the data link layer, the framing is done. It divides the data into frames for the transmission purpose. Error detection and correction is done in the data link layer. It detects and corrects errors in the transmitted data. Flow control is managed in the data link layer, so it regulates the rate of transmissions to prevent the congestion. And switches and bridges are the devices which are basically used in the case of the data link layer. Then the next one is the network layer. So here you can say the logical addressing is done in the network layer. Logical addressing like IP addresses to the devices are allocated. Then simply the routing is there, so it determines the best path for the data packets to reach their designation. Network layer is simply for the routing purposes. Firstly, the addresses are given, then the routing is done. So simply it will be decided that from where the data will be getting transmitted to where. Packet switching, it breaks the data into the packets and route them independently. So packets will be prepared in the data link, in the network layer only. In the network layer, the packets will be prepared, the addresses will be written on them, and then it will be routed to their designated addresses. And the devices which are used on the network layer is simply the routers. It is just like the postman service, postal services, you can say. Like the postal services, the network layer works. The data is simply divided into the packets, then it is addressed. Addresses are there, then the destination is decided from where till where the data is going to be transmitted, and simply the routers are the devices which are used on the network layer. Then the next is simply, okay, this image where you can see all the working in one liners I have kept here. Okay, now simply the fourth layer, that is the transport layer. So it is reliable for the data transmission, and it ensures that the data is delivered correctly without errors. So errors are already removed in the previous layers, but here also it is simply checked. Flow control, so it regulates the rate of data transmission to prevent the congestions. And multiplexing, so it allows the multiplexing, like simply multiple applications to share the single network connection. What is the meaning of multiplexing? It allows multiple applications to share the single network connection. And the different protocols which are used here: TCP, UDP. So TCP is simply the transmission control protocol. I have already told about it, that it is used in the transport layer. And UDP is the user datagram protocol, which is used in the case of the transport layer. Then the next one is session layer, which is positioned here. You can see the positioning is there in the image. So the functions are simply establishing, managing, and terminating the session between communicating devices. Establishing, firstly, that session will be established between the sender and the receiver, then it will be managed, and it will be terminated when the data transmission has been done. Synchronization of data is there. The next thing is the presentation layer. So, like data encoding, so it converts the data into the format that can be understood by the receiving device. That is the encoding of the data, which is done on the presentation layer. Presentation means that how the data will be readable by the receiving end. So encryption is done here. So encrypts the data to protect it from unauthorized access. And the comparison, so compression, so it compresses the data to reduce the transmission time. The data is compressed to reduce the transmission time. That is also done here on the presentation layer, because in that decoding is done here. So simply the encryption is taking place, and encryption actually have the features of compression of the data also. Then the next one is the application layer, definitely. And the application layer provides the service to end users, such as the file transmission, email, web browsing. And the different protocols which are used here, the rules which are used here, simply the HTTP, FTP, and SMTP. That is the hypertext transfer protocol, file transfer protocol, and SMTP, that is the simple mail transfer protocol, which are used here. Now, if we talk about the advantages of the OSI reference model, so standardization is there, and it is comprehensive. So it provides a common framework. It provides a common framework for understanding and designing the network system. OSI reference model. It clean separation of concerns. So it divide network functions into distinct layers also. Because there are 7 layers. So this is an advantage, because it is making it more easier to analyze and troubleshoot the problems.